Bienvenidos a todos. Benvinguts a tots. Welcome everybody. Welcome to Technocampus and Mataró. It's a real pleasure to host again this Spanish-German conference on additive manufacturing and mobility, organized by the Chamber of Commerce of Germany and the General Consulate of Germany in Barcelona. And we are really grateful because this is the second year that this event is taking place here. That means that your trust in Technocampus is reconfirming. So we are really glad about that. And today's meeting is special, relevant, because it brings together two industrial ecosystems with a great deal to share. Germany is clearly a benchmark in the European market in industrial ecosystem, especially in engineering, additive manufacturing, and advanced manufacturing, and applied industrial innovation. But on the other hand, Catalonia has a historical and very dynamic industrial fabric, and especially Mataró has a long experience in the textile sector. We still having two of the most important companies in textiles, in industrial textile in Catalonia is placed here. So we still having an industrial and historic fabric in textile. And why we think that it's really important to have this event here? Because we are really committed with innovation. In fact, we strongly believe that innovation has a real value when it connects with the challenge and real needs of the industrial sector. And Technocampus is especially committed with innovation because we are much more than an academic center. We have in the same place a tech park where we have a lot of supporting tools and facilities for entrepreneurs and businesses. And on the other hand, we are really believe that the tech transfer, it's valuable when it connects with the industrial sector. Let me say that this year we will launch, in fact, it will start in September, a new bachelor degree in AI and robotics that clearly expresses our response to the talent needs of the industrial companies. And on the other hand, we will have a new building. We start the construction of a new building just over there, a 1,000 square meter building that will really expand our capacity to generate talent, knowledge, and innovation. And this is why the conference like today fits naturally here. Additive manufacturing is clear no longer as simply an emerging technology. It increasingly becoming a strategic tool for industrial competitiveness. Through E3D, I think that some of you have been visiting last year, one of the Technocampus strategic initiatives, we work precisely in this direction, helping SMEs, industrial companies, and entrepreneurs to explore the potential of additive manufacturing. Regarding mobility is another our key field for us. Through Antenna Tech Lab, that is this space, is a project promoted together with Renfe and Mataró City Council, together with Technocampus. We support innovation and entrepreneurship in the field of mobility. This connection between the additive manufacturing and mobility is particularly powerful, and it opens the door to lighter components, more efficient maintenance, advanced materials, on-demand production, and new industrial models. Anyway, I hope that today's panels, presentations, and B2B's meetings will not be only a connection, but a place where you can explore synergies and start conversations that continue beyond this conference. I just want to wish you a very productive and inspiring day, and welcome to Technocampus. Então,
Okay. So, thank you, Claudia. Welcome everybody on behalf of the German Chamber of Commerce for Spain as well. First of all, there's plenty of space in the first rows, so nobody needs to stand all the conference. So please, you're welcome in the first row as well. So it's a great pleasure to welcome you today here at Technocampus Mataró Maresme, and to bring together companies, technology centers, institutions, and experts from Spain and Germany around the topic of great industrial relevance, additive manufacturing, and its role in the future of lightweight materials and advanced production technologies. I would first like to thank all of you for joining us today. My special thanks once again goes to Technocampus for hosting this event, and in particular to Claudia and to Giuseppe, that really supported all the organizations, the organization, and thanks for your cooperation. I would also like to warmly welcome Mr. Heinz, Deputy Vice Consul of the Consulate General of the Federal Republic of Germany, Thomas Nitsch, from our German business partner, SBS Systems for Business Solutions. Afterwards, when we make the first change, we'll have with us Linus Tillmann from Mobility Growth Additive. As a keynote speaker, Dr. Ignacy Gomez-Belinchon, a dear friend after all these years from InMove by Rail Group. So with a couple of events already in the field of railway. And Francesco Coloni from AX de Mataró will give us a best practice example. Additive manufacturing is no longer only a promising technology for the future. It has become an increasingly important tool for industrial innovation, offering new opportunities in design, production efficiency, material use, and third-phase manufacturing processes. And this is precisely why events like today's conference are so valuable. They offer a platform to exchange experiences, present concrete technology solutions, and identify new opportunities for cooperation between Spain and Germany. For the German Chamber of Commerce for Spain, it's a great satisfaction to support this kind of exchange and to continue fostering Spanish-German cooperation and innovative and high-potential industrial sectors. We'd like to take this opportunity to emphasize that today's event is being held on behalf of the Federal Ministry of Ministry for Economic Affairs and Energy as part of the so-called Market Development Program. This initiative is designed specifically to support small and medium-sized companies in their efforts to expand internationally. Allow me to mention a few organizational points. We'll be recording today's event and we'll upload the videos and presentations to our website shortly. We'll let you know as soon as they are available online. And one petition to our speakers: kindly ask you to respect your allocated speaking times as far as it's possible, of course, in order to ensure the smooth running of the conference. So you will see probably some yellow and red cards, so that will be advices that you're running out of time. So please sometimes have a look to me, so I will guide you. Networking is a key part of our conference. We have set aside a longer coffee break for this purpose, and we'll round off the event with a cocktail reception. So thank you very much for being here. Wish you a very interesting, productive, and inspiring conference. So, Mr. Heinz.
First of all, thank you so much for giving me this opportunity to address you today. Und ganz herzlich willkommen an die deutschen Teilnehmerinnen und Teilnehmer. I would first of all like to congratulate all of you to be here at this Techno Campus. I think it's a great place, a great space for innovation, which has been established quite some time ago and which is growing dynamically. And I think it's a good environment to connect and to come together. We have heard that this conference today is part of this markets development program of the German government, of the German Ministry of Economic Affairs and Energy. And this, of course, is important for you because you're here to do business or to talk about business, to find partners. For us, as a German government, it's a little bit more. In these days, in these times, we are challenged in Europe. We are challenged not only economically, we are challenged militarily, we are challenged in many fields, in the digital sphere, or model how our society's functions are challenged. And to come closer, to come even closer together within Europe is of key importance for our future. So you're not only doing business, or hopefully creating business opportunities today, but I think it's also a very important contribution to create a greater coherence within Europe, and also to see how much Europe has to offer. Because especially in Germany, maybe not so much for Spain, but we in Germany, we very often we are, let's say, we think, oh, our products are good, but we are quite. I spent, before coming to Barcelona, I was 4 years in California, and the Californian spirit is very different. So they're very excited about everything they do, and I think we all can be actually quite excited what's happening and what we create here in Europe. And I wish that today's event is a small part of this, that you see that actually we are quite competitive, not only in Europe, but also on a global level. And I hope that lots of talks are going on and lots of very specific cooperations are being born today. It is a very beautiful day, as you have mentioned. Thank you so much for your attention, and I wish you very fruitful discussions and successful meetings. Thank you.
Stop. I thank Dr. Heinz for your welcome words, and Thomas, please.
Yeah, thank you, Markus. Thank you for hosting us, and Christina. Thank you for being here. My name is Thomas. I'm from SVS. This is a partner company of the Chamber. We organized that thing here together, and the most important players actually are the German companies and you guys from Spain. So the idea is to network, to get some introductions to information from the German companies, but to mingle, to network, to talk to each other. Here we have prepared a card with a QR code. They get all the information about the German companies, their contacts. That's important. That's on the tables over there. You can pick that. And to get an idea how to network with the German companies who will speak, just an introduction to the guys that will do their presentation, talk about their companies right now, in the order of the presentation, so you can remember the faces. It's easier to get in touch then. So the first one is Hans Alfred Bräuninger. Just get up, stand up, show your face. Hello. He's a very experienced consultant in additive manufacturing. The next one is Fritz Lang from 3D Spark. Fritz, please. Okay. And then we have from Qualified AM, Gregor Reichler, where he is over this. And the last one in the first set for 4 companies is Christian Galking, the CEO from Nanoval. That's probably our tallest guy, actually. So then we have a coffee break at the panel discussion, and then we have another 4 companies. That's Patrick Consul from Lean Technologies, and we have the colleague Benno with you. Benno, just get up. Yeah, these 2 guys are from Lean. Orion Additive Manufacturing, Adam Ramville. And then Top Model Fabrik, Michael Kohlbecher, where he, yeah, Michael. And then last but not least, from CTZ in Stade, Mark Fette and Mark Meyer. be there. So this will be 4 + 4 presentations, some keynotes from Linus. Linus, please. So the next one is him, from NBA, Navigability. And thank you for being here. I hope this will be a fruitful event. Thank you.
I think we can quickly change. So it's Linus, please. Ignacy, or come here as well. And Francesca, please, if you want to join us as well. So, Linus, I think you need now a big introduction. As already said before, he comes from or represents the German Association Mobility Goes Additive. And well, he will talk about We Boost AM.
Yes.
So, please.
Thank you very much.
Great.
So I'm from MGA. We are the professional association that initiated this joint travel to Spain. And I just want to very quickly show you what's or a part of what we are doing on a daily basis in MGA. We are the leading European network for additive manufacturing. We do have 2 divisions. We started from mobility, getting into all industrial topics. And then we do have healthcare as a second division, which I'm not completely responsible for because I'm the industry guy, but I do have a colleague that takes care of the healthcare topics. So what exactly is MGA? We are an association that at the moment consists of 130 member companies from all over the AM supply chain. Of course, the focus is always on the users. We do have service providers. We do have the most important machine manufacturers, institutes and universities, software companies, consultancies, standardization experts, and consultancies, and as well material providers. So in this network, it's not just about a normal exchange and networking, but it's really a topic-driven network that we do have. We always try to engage more people into additive manufacturing, bringing information out, but as well solving the more global problems and hurdles that we have in additive manufacturing. One of those streams is user and application focused. In orange, you do see the industrial topics like public urban transport, reliability, lifestyle as well. And in blue, it's the healthcare topics. And then, of course, defense. We do have both of the topics engaged in that. And in those topics, we normally do have working groups if they are active. And those working groups, they organize themselves. For example, reliability is a group of the big European rail providers that are part of the network. And they use that our closed group there to exchange about real parts, about real applications, about experiences with technologies, materials, providers, and so on to get more directly into more applications in the rail sector, and especially as well with an eye on the certifications, what's already possible, and so on. Then we do have groups like defense, where we do not have all the big OEMs and the users directly in the network because that businesses are dealing with that a bit differently, but we invite them to have an exchange with us on a broader base. For example, with the German armies and the other European armies, we had exchanges with other bigger OEMs in Europe already, and then we meet and then we exchange on topics that we think are important, or just to get into contact with them. On the medical side, it's quite similar. As an example, it's hospitals. Here we do have European hospitals. We are as well in a good exchange with another hospital network that are active in additive manufacturing and trying to foster projects there, bring AM forward at the point of care directly. And we as well going into, for example, pharma and bioprinting, which is not just about printed drugs, but there as well, you do have a lot of hurdles and certifications that are industry specific, and then we try to go for them. The second stream is market development that we are taking care of topic wise. For example, on material level, talking about supply chain topics, about education, which of course is the foundation of bringing AM forward. For regulatory on the medical side, for example, we went very deep in our network into the MDR as the main driver in the medtech field, talking about the classes in the MDR and as well about what is already possible in terms of those regulations. And then sometimes we as well publish white papers, other things we just hold into inside of the network as our asset and IP of the network itself and just share with members. Yeah. Presenting information was always a thing for MGA. So this was one of our very first outcomes. It's kind of long ago, but we wanted to help people as well getting onboarded into the technology faster. And of course, in bigger companies, that's as well about implementing AM in the right way to save time and to get more directly into printing and into going for applications. We do have We Boost AM, not just as a slogan, but as well as a platform. There will be a new version in the coming weeks, but you will already find an overview of standards that are important for additive manufacturing. You can filter them as well as the material overview or our training system, which is modular and can be taken by everyone. So we invite them, and some of the bigger companies like Siemens or Alstom and so on, they already implemented that for their internal trainings. Yeah, other projects that we did is, for example, talking about desktop printers. You may know that we do have a Chinese problem there, but we do as well have European-based companies like the German Army in that case that came to us and said, we do have a tender ongoing and we want to buy the right ones. But then we sat together with some desktop printer providers and with other industry participants talking about what exactly do we need from, for example, Prusa Ultimaker to have a real printer that could be competitive and could be a solution as well on the software side for additive manufacturing. We're talking as well about approval topics very specifically, and that case about rail approval. This is the first 3D printed safety relevant metal parts in rail. You can see we did that already in end of 2020. It was just an approval on regional level. And just in 3 weeks, we'll finish the second phase, which is an approval of a very similar part on European level. And we'll build this in, I think, beginning of or end of June. So we already got the approval there. We did a lot of testings around it. And then we as well went for a joint funding project in that case to make this available for more people, because we learned a lot. We brought this into a digital digital process. We talked about risk classes and so on. And at the end, we want to have a calculated strength verification for AM components so that we can save testing and, of course, save money and time by that. Getting more into regulation, we did a lot of as well in terms of standardization. For example, the 52920 that Gregor will probably talk about later as well. One of the very first international standards that we had was the foundation for that was laid in our network as a qualification for suppliers that was then developed into that international ISO standard and was the foundation for that. And we tried to do a similar thing on polymer side to gain more trust into our materials. You may know that there was now an initiative for the metal side, which was already published on ISO level. And we are doing the same on polymer side. We had 2 or 3 years talking with all those polymer providers about their testing and their way to do a data sheet. And we want to derive this now into an international standard as well. Yeah. And then it's not just standardization as overarching topics, but there are a few more that we as well do. For example, talking about sustainability, but as well political engineering. For us, it's not just the political engineering in Germany, because we are a European network. We do have members from more than 10 countries in MGA. and political engineering gets more and more important, especially in those economic times where we are missing funding and where we really need to do more about getting this public money as well for boosting as well innovation in additive. And for example, one example for the political level is that we, together with our friends from Leitat, I think David is here as well, we founded that at Lions as an umbrella organization as well to have more an exchange at one voice with all the national clusters, with all the regional clusters that we do have in AM, with all the hubs to come together, have an exchange, don't do work twice. That was quite important for us to have a better exchange there. Yeah. And then, of course, last point, I want to invite you, if you're interested in the network and don't directly want to become a member, join us at our annual meeting in October at Berlin. We are celebrating 10-year anniversary. So, yeah, happy to have you here and go into it. Thank you.
Hey, Ines, thank you very much for presenting NGA, your activities, and what will be next? Now, Ignacy, please, what's going on in railway systems and manufacturing?
Yeah, thank you very much, Chamber of Commerce. Thank you very much, the attendance. I will just try to make some tips onto the cluster management related, first of all, related to that. He was mentioned by Mr. Heinz that we need to react. We need to react as Europe in terms of all the scenarios that we have. And we cannot stay in the same way as we used to be because of uncertainty, digitalization, globalization, future of work, blah, 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 etc. And we need to decide if we remain unaffected, accelerated, new scenarios, lowered, etc. This is something that in terms of a new technology, new appliances is crucial. But our point is not just because of having an interest into the, let's say, pure technical or technological issues, but also the appliances of these users. This is the cluster thing. And of course, as a cluster, how these efforts be more impactful and also to the needs. This is questions that maybe I will offer to you. And also, another conception of the railway is not railway, it's livable mobility. Mobility is something that will help us to do our lives. If we add sustainability, then rail is great because it's 9 times less CO2. It's comparable to an electrical bicycle in terms of CO2, blah, blah. But we need to reverse from shift from verticals, automotive, micro-mobility, rail, etc., to mobility, livable mobility. To this end, then, our focus, I'm sorry if maybe some OEM is here. John Maldesa from Alstom is expected to be here. I didn't see here. But, the point is operators. Jaume, you know very well my point. The point is operators. And these are the prescriptors of manufacturers. But they do it quite well. But it's not, again, infrastructure. It's much more related to the new urbanism and cross-sectoral combinations. It's not just pure rail. Yeah, as a cluster, we have more than 100 members. We create ecosystems. We are, as it was mentioned, we have a value chain related to these scenarios. But I would like to emphasize this meta cluster that we were founders. Currently, it's more than 17 members all over Europe, from South Portugal to North, Denmark, etc. 3,000 SMEs, 80% of contact with a technological offer in Europe, and this is very powerful for a European project that for combinations and synergies. This is very powerful in terms of creating, as Mr. Heinz mentioned, this new focus for Europe. What about our main efforts? Well, of course, mobility should be sustainable, safe, reliable, of course, but also related to know, to work a path. That is, we need to dedicate data spaces to that. We need also to be close to the customer needs, the reshaping of urbanization. This is something, and the use of public transport. Without public transport, the backbone of rail in Europe cannot be done in terms of sustainability. How can we deploy that? Maybe we offer you to think it over, and we do work out these scenarios in terms of customer-centric operations, uses for mobility, advances material, not just this type of AM, infrastructure resilience, connected, cooperative, automated mobility. This is something that for us is a way to progress in terms of appliances for infrastructure and defense manufacturing. We have been related to upwell 110 million euros in European projects to this end, and it's a lot of room to roam in this area. Safety, of course, condition-based maintenance, new interiorism, and multimodal logistics. We create an ecosystem based upon knowledge, provide knowledge, who is doing what, who is able to combine with you. Then, of course, try to get insights from this cooperation through a lot of events, more than 100 per year. And finally, try to be concrete in terms of innovation. Innovation is something that when we show off the advances in innovation, then this is a return on value magnificent for understanding that these new scenarios are the ones to which we need to focus. Yeah, some. I'm sorry because we have many more members, but have selected just some of them, including Aston, of course. Woptec. Freight is a very good area for AM. Very good area. And Woptec is quite very well placed in that. The ex-Fable 8, maybe you may remember Fable 8, and they are focusing in solving urgency, preventing obsolescence, optimizing stock and procurement cost, past performance, function segregation, reduction of weight, and local production. These are coming from Woptec in one of our workshops that in December price here. Another classical one. We were conducting together with Recad and Alstom the first project on appliances of AM with Leitat. Sorry, not the Recad, Leitat. Also for HP, Hewlett-Packard with CAF, appliances for rail. And we think that they have also very much to say in terms of AM. Leitat, of course, Leitat is another reference in that end. Reduce production costs, lower vehicle weight, speed up design validation, and many more, developing high efficiency tooling. You will have this presentation, so I cannot have to spell every single phrase that we have in the presentation, especially I don't want to have the red light of my presentation. Right. But quite interesting because we offer you the points to attach in your probable efforts in AF in our geography. The Recad, of course, and they are doing and promoting this this project. Is an overall project over 2.7 million euros, ending in February 2027, and it's not the last one. So in this area, Recad has an agreement with Technocampus, and I think we may follow up the consequences, and specifically my point of view is the appliances of the conclusions of the project. Okay. And Renfe is the president of our cluster, and they have created, they have begun to manufacture spare parts for its trains by 3D printing. They have created specific premises close to Madrid to do all that. Some of the examples you have it here, but they are thinking not in metallic parts as is quite wide, but onto spare parts. It seems that they are doing so, but at least they have produced these first outputs. And Alstom is implementing additive manufacturing to reduce costs, optimize design, and streamline the production of spare parts in the rail sector. But maybe then you can talk to them, but they have some lessons. First, the quantity. Minimum quantity. It was stated in past year, one of our past year workshops, minimum quantity 400 pieces. This could be a barrier. Also, plastic and metals in specific areas is difficult, the variability, etc., etc. You will have this presentation, okay? But then also they need resins. They have needs in aluminium and hybrid fabrication and many more. You have it here and you have the contact. So, and I think this is going to be my almost last slide, because yes, we have some key benefits of this technology for the operators. If we lean on them, we will have the attention of the operators, but it's not easy. Minimum quantity is 400 pieces. So have a look out from the trainee too. That is, it's not just the train, it's the operator, it's the station. These could be some areas of interest from our point of view. But additive manufacturing as a conclusion technologies, despite the high material localization and the ability to rapidly construct complex shaped structures of 3D printing technologies, the application of additive manufacturing technologies in railway track infrastructure is still at the exploration stage. This is for me the conclusion. Exploration means observe, share, and progress. Thank you very much. Dankeschön. It's a pleasure from my side.
Perfect. Well done. Thank you very much, Ines, for this overview of what's going on in your cluster and what's your perspective of the near future. So, Francesc, thank you for being with us and sharing this best practice from Iris de Mataró.
Okay. Thank you very much for Technocampus and Thinking TV for inviting my company to explain our experience. I must confess that I feel as an intruder because I don't have any experience in 3D printing technology and also not in additive manufacturing. But I will tell one story, and I hope that could be inspiring, because we are sharing our experience in this technology. We are, Aguas de Mataró is a century-old company. We are very ancient. Our laboratory has more than 125 years, and we are the typical public utility company. We manage drinking water, sewage water. We have a district heating, and we have a public laboratory. We also manage solar plants, solar energy plants, and this kind of service also impact a lot in our culture. We have a strong service and quality culture, but we are not an innovative company. Why? In this context, our approach to the 3D printing did not emerge from a real need. We don't need this technology, but we use the service of the thinking 3D as a deliberate way to foster the curiosity, the experimentation, and to try to change the mindset of our company. It's our weakness. Our long-term reliability-driven environment is essential, but it doesn't naturally raise up the innovation. We want to increase innovation in our company. It doesn't mean that we are a very conservative company. We have a high degree on digitalization. We are working with EA tools. We made important contributions in open source softwares. We are early adopters. Usually we are early adopters in technology, but we are not an innovation company. We want to change this point in our organization. We designed an initiative that need to be simple, engaging, and inspiring for all the people of our company. But to jump one step, we decided that it was necessary, any prior knowledge on 3D printing. We didn't organize it. Any course about 3D printing design, nothing about 3D printers, nothing. We decided the only requirement for participating in this initiative was to solve a real problem from our daily work. To encourage the participation, we introduced one playful competition. We created a sense of competition, of course, with a humorous environment, and we promoted the idea of one exceptional prize to generate excitement between our workers. We are a small company. We have 100 workers, and we have very different profiles. At the end, people generally wanted to participate. We have 5 teams, 15 participating, and 6 prototypes. I will explain what was the prototypes and what was the product that we developed. The first was an wet, a reinventing Legionella sampling. When you take samples for microbiological analysis in the context of public health surveillance, one of the key points is to take samples from hot water systems. Hot water systems, for prevent Legionella growth, usually operate a very high temperature, more than 50 degrees. And it's very easy to become wet or scalded when you take the sample. The solution was to develop a specific heat with multiple positions with different inner holes to adapt to most conventional serving bottles, plastic, square, rounds, glass. And the benefit is that it's very safer for the technician, it's more efficient, the process, and also prevents cross-contamination in the moment to take the samples. The design is this heat. The other is a mountain walking stick that we purchased in a mall, in a Decathlon store. We have different tools like this daily operating between our sampling teams. The other one is a cabinet. It's a sustainable coffee capsuloid solution. It was a conceptualization from our environmental team. As you probably know, a coffee capsule contains 2 different materials, coffee and aluminum. It's a problem to manage this residue because it's not easy to recycle, and we've tried to separate all the residues in our company. With this simple design, we can, with this position, with 2 different plastic blades, you can remove the aluminum foil, and the other one is something like a manual orange juice maker. You can remove the coffee from the aluminum capsule. It makes easier the recycling process, it reduces the environmental impact, it makes simple and user. It's a simple and user design. Whoa. Okay, this is the other one. It's a smart hydrant signage. It's still not implemented because we are testing the resistance of the materials in the real condition, in the real environment. But for us, it's one of the most potential things. In stage, we have different signals, especially for the hydrants, for the firefighters. And it's a plate with information about the position, about the pipe diameter, about the type of connection. And this signal is a very important signal for the firefighters because they can detect and understand where it is placed, what kind of connection they have in to fight against the fire. This plate can be easily printed, contain additional information, and also contain an NFC card to be connected to our databases. It will allow a real-time access to the information about these installations, and also this concept of plate can be used for a lot of objects that we can find into the streets. It can be applied for trash containers, for bins, for street lamps, for islands, and whatever you want. I think that with this technology, we usually can apply our operational maintenance operations more efficiently, but also the citizens can communicate incidences to the city council or to us. The third one is the rack tracer, is a cable identification. This tool also exists into the market. It's expensive and also has a surprising trend to disappear. One day you have two of these instruments in your desk, and another day nobody knows where they are. This team designed one tool that can be plugged to a mobile phone and can do the same functionality. The functionality is when you are working in an informatic rack with different servers, different switches, different hard disk drives, you have to plug a lot of cables. You need to recognize the correct plug for the network cables. And they usually use one light to put and to localize the point of connection. With this tool, you can do the same functionality, but a lower price and using a simple mobile phone. Okay, this is the piece. It's not a medieval torture instrument. It's one very simple concept that nobody previously think on that. When you are removing weight meters in very old buildings, there exists a critical operation. It's the moment that you disconnect the water meter from the lead pipe. In this moment, usually the lead pipe fell down, and it's very easy to have a breaking point and a water loss. With this simple piece, we can do. Okay, we are near to finish. We can maintain the water pipe in the same position without risk of damage. The last one is the water laboratories are moving to glass or plastic bottles to a plastic bags. It reduces a lot the plastic consumed, but also has a problem of handle these water bags. With these racks, our sampling teams can handle better the samples, and it's very easy to transfer to the laboratory, and it's very functional and very easy to work. The magic prize was a simple glass pitcher for the winners, but everyone received it at team lunch. The winner was the no-wheat because it was very practical. It was a success during the balloting, a secret balloting. The strategic message, despite my presentation, I think I'll be very quick, is that we are able to obtain an own mindset for a long-term organization. We introduce experimentation, we accelerate learning across the teams, in which strengthening our ability to adapt. But one secondary success is that all of these pieces are on use at this moment nowadays. Thank you very much, and I hope you enjoyed the presentation.
Yeah, thank you very much, Francesc. As you said, early adopters, so I think that's an important role as well as that you're executing. So thanks once again for sharing this experiences with us. And well, Now we'll open our first panel. So Linus, please, the floor is yours.
The floor is not just mine, but I would really like to welcome the six panelists. So the idea is that everyone has a short speech as well, like up to 10 minutes. We are not very angry if you keep it a bit under those 10 minutes to get time back. And then we'll have 15 minutes or the rest of the time to have a panel discussion here. And maybe I do have some questions, or we'll open the questions then as well to everyone. Okay. So I welcome on stage first Jenis Portasi Maswiker, the coordinator of the 3 Digital Manufacturing Labs. Then Josep Maria Montero Calzado from Technocampus. And then our German guests that were already kind of introduced, Heinz-Alfred Bräuninger from Bräuninger Consultants, then Fritz Lange from the Sparks, Gregor Reichter from Qualified AM. Gregor? Where's Gregor? Okay. And then Christian Gerking from Nanoval. Please come up here. I hope we do have enough here. The best. Okay. Think you can start. Here's a presenter.
Thank you so much. Okay. Good morning, everyone. Thank you very much, Linus. Thank you very much to the Chamber, to the Technocampus, to having us today here. It's a pleasure. I'm going to go very quickly through some slides. We have 10 minutes. You will have the presentation. My main goal is to generate awareness of what is EURECAD and our capabilities in additive manufacturing. So, EURECAD, some of you might know the organization is the main technological center from Catalonia and one of the largest private research organizations in the south of Europe. Our main goal is to accelerate innovation, reduce the cost of scientific and technological infrastructure, and reduce the risk for the companies so we can innovate with them. We are very oriented of research with the market, with the companies, okay? We have a multi-sectorial and multi-technological approach that I'm going to explain a little bit later. Most of you know about technological centers, but to make the point, if we have a look to the discovery of knowledge, to the research, to the universities, and then to the other hand, we have the business that is exploding that knowledge, okay, making businesses. We usually have a gap between these type of organizations and between the workflow of how we generate and how we explode knowledge. So technological centers, we have the main focus on bridging this gap, always with a very strong focus on the market. Okay, we also work in basic research, but we have a very strong focus on making the technology to the markets. At EURECAD, we have 4 main technological areas. I'm representing the industrial area, but we also work on the digital area, biotech area, and sustainability. Okay, I am representing the industrial area. That's where we work and study advanced materials and processes, among other technologies. A brief of our offer, mainly interest of today is we do applied research and technological development, very strong focus on technology development. We give services, technology consultancy, and a specialized trading also. Here is important because we are results oriented and we work with the companies when they need us. maybe in the beginning, an assessment of an early project on a proof of concept or industrial scaling. But we work from the beginning to the end only when the companies need from us. We have 11 sites in Catalonia. We also are in Madrid, Malaga, and in Chile. Some numbers. On 2024, we have an income of 69 million. I believe the past year were 75 or 76 million. This is a very important number. 70% of our activity is related with small and medium companies. Okay, and this is an important point for us. We also are very strong with IP generation. We had 230 patents the last 10 years. And the point of this slide is that the past years we've been extremely competitive in EU funding, okay, in research from Horizons and other programs. On additive manufacturing, very briefly, we work with materials, processes, and products all across the value chain. We have multi-technology teams. We have a team for metallic materials, polymeric materials, processes, so we can do projects all across the value chain, okay? And we also have academic training and a strategy and consulting department. Now I'm going to go inside some of the points because we have a lot of technologies. Some of them might be of interest to you today. On materials, we develop materials, metallic powder. Okay, we have two main technologies. The first one is gas atomization. We can manufacture small quantities of high add value powder with precise chemical composition and very good spherical morphology. Okay. The second one is the microwave induced plasma technology, also used for cover powders. This is a very interesting one because we can have powders from AM processes, polishing, other processes, powder that is waste, and with this technology we can recover and reintroduce as feedstock to AM technologies, mainly laser powdered bed technologies, but there are others also. This is a technology we have patented. I believe that we have a video. The plasma, the microwave, produce a ionized gas that allows us to work with plasma, and here we pass through the plasma the polygonal that are not good for processing with additive particles, and as a result we have a very good particles in density and with morphology, very spherical particles. It's a compact solution, so we are scaling the readiness technology. Now it's at level 6, I believe, but at the end we want that companies can have this in their machine shops to reuse their own powder and scraps from the processes. We also develop tailored polymer solutions for additive. We can custom, we have compounding and extrusion. We can work with recycling materials, fibers, wherever, and also we can characterize all the material and also for the processing, the correct processing of new materials. Mainly we've been working with materials for extrusion, not polymeric or powders, but we did one project only about polymeric powders. About characterization and testing, we have a lab for polymeric and a lab for material testing. You can find the information in our website. We are working on advanced testing methods. And this is very interesting because, for example, in the first case, we did the fast track test. With traditional method, these tests, you need from 4 to 5 days. With our approach, we can do the test between 5 and 10 minutes. With additive, that one of the problems is that we don't know
properties of the final part. We don't know sometimes how the process is affecting us. We need new advanced methods that we can go at a fire pace and go quicker. Also, for the fast fatigue, that with the traditional method we had from 5 to 10 days, and we can do it in 8 hours. This is one of the projects we believe we add value and generating this technology. From the product, we have a very good design team. We have design for additive manufacturing from generative topology, computational design, simulation, multiphysics, multi-scale structures, and also process AM process simulation used for in metals, for the supports and others. We work with different softwares, and we have knowledge all of them. We also develop applications. As I said, our focus is on technology development, but sometimes companies need our help to develop applications. Here are some examples. This one might seem very easy. It's a tool for composite manufacturing. This goes on an autoclave at a very high temperature and pressure, and it might seem normal, but this goes beyond the state of the art. The actual materials developed for these applications go up to 110 degrees on autoclave. Now we are reaching 180 degrees, so we can have very good final properties on the part. This is for space, so we have very high requirements, and in this case, any non-technology or material was capable of doing this part, so we helped the company to develop the application. Other examples, for example, in hot stamping tooling. Okay. From the process point of view, we have some technologies. We don't have a very large portfolio of technologies. We work with service providers if we need. We have some extrusion, filament, granular from ceramics. We also have some bad photopolymerization, some sintering from powders, and also powder bed fusion for metals. And here, for me, it's the most important slide. As I said before, we are focused on technology development. For the past 15 years, we've been generating new technology, new patents, from ultrasonic deposition molding to silicon additive manufacturing, technology for continuous textile printing, the stent additive manufacturing processes. Here at the top, we have a picture from a stent of cardiovascular prosthesis that is very difficult to manufacture with traditional technologies. We have additive manufacturing approach that we are trying to push to the market, and some others. For example, the FEFIP, that now is a spin-off of a startup called Reinforced 3D, you might have heard about, that is a post-process for reinforcing through fibers some additive manufacturing parts. So our focus is to develop technology and go beyond the needs of the market. We also have some initiative, joint research unit with the MIT from Australia, and a manufacturing lab with the University of Girona. Here you have my contact for any further questions. Thank you very much.
Thank you so much. So let's directly proceed with Satya.
Hello and welcome to Technocampus. I'm going to try to be quick. Okay. I'm the technician for additive manufacturing for Thinking 3D. Thinking 3D belongs to Technocampus, and we are the 3D printing accelerator. Okay. Our main goal is to help companies adopt 3D printing as quick as possible, as easy as possible. So after that, they can go to the private companies and keep working with them. But we try to help with all this. everything related to 3D printing, of course, from design, 3D scanning, prototyping, choosing materials. Okay, but what happened with all of this? Okay, in this case, I'm going to talk about our case with Vueling. Okay, we usually work with very small companies from car workshops around the area up to companies like Vueling. You might think that Vueling have a lot of money and power to hire someone else, but I think our approach is very honest, and also we build a lot of trust with them. So after that, we can help them choose which technology or the path that they can take. Okay. Um, don't worry, we don't do any critical with them. You are safe with the Vueling airplanes. Okay. We don't touch anything that puts anyone in risk. So, but we try to help with some business cases that might look small, but they are very important. And I'm going to choose this word because this, I think, planted the seed on them to trust in 3D printing. Okay, they had a very big problem. These are the headphones that the captain and commander wear. Okay, and believe it or not, the airplane window opens like in a normal car. Okay, you can take your head off if you want, and they open very. It's very usual that they have to open the cabin. So they used to put the headphones in some places that break the headphones. Okay, they pull from the cable, they fell. Okay, and if it breaks, the airplane can't fly. Okay, so you can imagine you have your airplane in Bilbao, it breaks, you have to find another one. Every minute that the airplane is on the airport, it costs money, delays, blah blah blah. Okay, so they challenge us and they say, "Can you find a better place to put the headphones on the airplane?" And we say yes. Okay, we are going to try to do this part. So as you can imagine, this is a business case that a part that cost a few euros can save a lot of money. So we 3D scan everything, we design something, and in 15 days, we have the first prototype. It's a video. I don't know if it works. After 15 days, we went there with the first prototype. It worked first time. So I remember being like this eureka moment for them. Like, okay, this is going to work for us. Also, you might be thinking that a part like this couldn't be on an airplane, but there is like a gray area that says that anything that is not bolted to an airplane, it doesn't have to go through homologations. So, of course, this is clipped in. It's not bolted. So it works. Everybody was happy, blah, blah, blah. But then we have the first, this picture. I put it there just to like, I put this phrase like the result is not only the peace, the savings, the satisfaction, but a collaboration that still lasts to this day. So we created this trust. We planted the seed that 3D printing can work. So everyone was happy. But after that, of course, we had many failures, parts break. We have to go through many iterations. We are now in the B4. So you can imagine they have realized also that this is not perfect. We'll go through many iterations, parts break, etc. But after that, they keep giving us challenges. Like for example, this is a torque wrench for disassembling the screens, the front windows of the airplane. You have to put a lot of torque in them, and the operators have to put the chest on the tool. It was very painful, so we developed this tool to have them put more torque in the part. And also we have developed this part here. This is the IDG of the airplane. This is the alternator of the airplane. They have to disassemble many times, and the existing tools are rubbish, basically, so they don't use it. They pull it down by hand. So we developed a tool fully 3D printed with cheap plastic and everything. And it helps them to put the IDG down, you can rotate it, you can tilt it. It's very useful. We are now working in this, but I think that was the last slide. This is a video that shows the whole process with them after we finish like the first year of collaboration. It doesn't have any audio, but it shows the part in use. But my point is that the success with 3D printing, it's not only the machine itself. The machines are very useful. It print everything, but the design, thinking about 3D printing or thinking about conventional, this is the kind of things that we are trying to teach companies, okay? And after that, of course, when they want production, when they want a step forward, we send them to the private companies. So we don't want to be seen as enemies, let's say. It's the opposite. We are working for you basically to have more job with companies in 3D printing related things. So yeah, this is the tool in use. Yeah, this is a pilot. So yeah, I think without audio, the video doesn't have many sense. But this is my point, and we have also some perks from this job that you can see on an airplane. So thank you very much.
Yeah, thanks for presenting in front of you. I brought two subjects. One, an overview on the global AM market, because I think that's quite interesting what's happening on the global market. And then I have some ideas how we could develop more business between Spain and Germany on focus of AM. My name is Hans-Alfred Bräuninger. I got a master in chemical engineering and I got my MBA from INSEAD in France. And I was 35 years consultant for change management subjects. And to implement AM is also change management. So I'm really familiar with how to change the mindset for new technologies that I love as a subject. I was a consultant for Stratasys for 5 years. And I'm now more than 10 years independent consultant for AM. And so I'm completely vendor independent. So I'm a neutral person in this market. I'm not depending from companies, so I can give you an honest advice what to do. I'm a founder and member of various AM networks, because in AM you have more than 60 different technologies. And you cannot cover all the technologies. You need networks in AM because it's very important to understand the whole industry through networking. Not one single person can cover all the 60 different technologies which are in AM right now. There are two interesting market studies in the AM field. And I also want to answer the question if AM is disruptive right now or if it's more in an evolutionary growth. First of all, AM is 0.01% of the global manufacturing market. So the market segment of AM is very, very small. There are two interesting studies, one from Wohlers Associates. They do it now since 30 years. And one from the German company AM Power based in Hamburg. They have completely different approaches, but the global AM market is between 24 billion or 11 billion. And if you take Nvidia, one of the most successful US companies right now, their quarterly turnover is 40 billion. So the market size of AM is only 50% of what Nvidia is doing in 3 months. So we are really talking about a very, very small market. And this market is also in a really big restructuring phase. So BASF went out of the market, Trumpf went out of the market, Covestro went out of the market, Desktop Metal is almost dead. So it's really a very big restructuring phase, and not many companies are earning really good money in this field. It's a lot of
subsidizing, and the market is really reshaping right now. So you should bear this in mind, that it's still a market which wants to find the right solution. You have more than 400 companies who offer AM hardware and materials and things like this. If you take, for example, the 2D printing market, this is our printers, copying machines. There you have only 10 suppliers, and this is a very stable market. And in the AM market, you have much more than 400 or almost 500 suppliers, and the market is not very profitable, and it's not from my point of view, in a really equilibrium. So it's interesting in which market we are in. The most growing segment in the AM market is China right now. We had last year 30% growth in China, and in 24 and in 25 we had about 20%. And so the market is shifting to China. China is growing internally very strong and also externally very strong. If you remember the famous Bambu Lab story, Bambu Lab is now the market leader in the desktop printing segment. They have much more than 60 or 70%. And also the industrial AM machines from China, like Farsoon, like E+, or like BLT, they are very stable, also quite, you can buy them for decent prices. For example, Trumpf, I come from Stuttgart. Trumpf is also a famous AM company, but they sold the whole business because they couldn't compete against the Chinese. So China is really growing, and there are several reasons. One is in Europe we had closed material systems, like if you have a Stratasys 900, you must buy Stratasys material. And this was not the case in China. They always had open machines. They always were free in their thinking, and so they were more innovative, that they had no barriers in thinking. And this is one reason why China is so strong. And the other reason is that China really got into certain applications which are very successful. So there is a shift from selling hardware in applications like the shoe business. So the Chinese really managed to change from hardware to very interesting applications. And to answer the question if the market is in an evolutionary stage or a revolutionary stage, the revolutions are only in the application fields. If you have, for example, the hearing aids, 95% of the hearing aids in the world are printed right now. And the change of the market in the US was within 500 days. So the companies who did not change to 3D printing in the hearing aid business, they went bankrupt. So you have just in the revolution in AM in specific applications, not in hardware sales or in material sales or something like that. So to answer the question, overall evolutionary market, and you have in specific applications the revolutions. Also, like in the Invisalign, what's growing very strong, the dental brackets. It's always in specific application fields. So bear in mind, if it's a market which is a little bit shaky, and a market which you have to find your right position. And there are still a lot of companies who go out of the market, like Arburg in Germany closed down, Trumpf sold the business, BASF. It's not so stable that you bear that in mind, that the hype is gone in AM. The hype was in 2014, 2015, when Obama said we will have printers in every home and things like that, these times are gone. Now we are at the stage of industrialization, and this comes just in specific application fields. So this is maybe my message to you concerning the AM markets. It's in a restructuring phase. The applications are becoming more and more important, and China is growing and has a always greater market situation. It's so, bear in mind, China is really coming, and I hope to say this from a German point of view, we lost all the solar business from Germany. We were a very leading company in the solar business 2010, 2012. I hope that we will catch the situation that we still have our leading position in AM, and that not the solar thing will also do the same in AM. So that's my wish. Now I come to the second subject I brought with me. I'm a consultant since 10 years for AM, especially in Germany, but I also know the international market quite well. So if you are interested in specific AM market segments coming from Spain to Germany, I would love to open you doors in Germany to give you market overviews. So tell me in which segments you are interested. It's in spare parts or it's in industrial prototyping. I can give you a market overview and help you to enter the German market. So my message to you is, if you need some specific information on the German market, let me know. I have access to the most important networks. I know a lot of their working groups. I'm, of course, a founding member of Mobility Goes Additive. Mobility Goes Additive was founded in 2016. I was there at the foundation ceremony. And I also can give you access to industry bodies or to conferences, or also increase your awareness and get you interesting contacts in the German market. That's my offer to you.
Yeah, hello everyone. My name is Fritz Lange, representing 3D Spark here. First of all, I brought a small video with me. See if this works. Is there a way to play it? I don't know. Anyways, let's skip the video for now. Have to hurry up, I heard, so maybe that's a good point. What's the problem that 3D Spark is actually solving? So what we see is that there are a lot of inefficient make or buy decisions, and procurement costs millions. So imagine you have a very specific component that you need just now. This might be prototype, jigs and tools. You have a new design that you want to test out, or also a big business, obsolete spare parts. Normally, you first have to make the decision: do I actually want to make this myself, or do I want to source this component, or do I want to buy it from one of my qualified suppliers? For each of those answers, you actually have to do a lot of things. So if you think, okay, I want to make this in-house, you first have to check the feasibility for your component for the specific manufacturing technology and material combination. You have to calculate costs. If you are a procurement guy, maybe you're not that aware of the cost structures behind the technologies, so you might have to consult your internal experts. You have to estimate manufacturing times to get an idea about the lead times. And maybe also you have to estimate the CO2 footprint. Same goes for if you want to think about buying the component. First of all, you have to research qualified suppliers in your network. You have to identify the ones that actually can handle your specific request. Then you will send out RFQs to them. You have to wait like 7 days to get quotes from them, and then you can make an informed decision. You can select the best quote.
And if you have done this for your internal manufacturing capabilities and the buy side, then you can actually compare, do I really want to manufacture in-house, or is it cheaper to outsource it to one of my qualified suppliers? Now you have run through this process for only one technology and one material, but maybe you want to compare casting, CNC, additive manufacturing, different materials. Maybe you think about changing the material for your application. Maybe it is a spare part where you ordered like 20,000 parts 5 years ago, but now you only need 5 components. So you will definitely not cast this component anymore. And then you have to run through this process again and again. And this is just a very costly process. What we see is that it comes with very high lead times. So like 7 days to up to 6 months, depending on your specific component. Talking about spare parts, this means asset downtimes, penalties, lost revenue. It comes with opportunity costs, and also you need a lot of internal experts to answer all those questions, and also sometimes quite some software tools that are included in this process. So that's the problem that we're trying to solve, and for that we developed a 3D Spark platform. This basically enables you to put all your data, like this can be the 3D CAD files of your components, technical drawings, even just images of the components, meta information, your PPM system into 3D Spark. We will do the printability check, technology comparison and selection. And this is then based on the manufacturability of the technologies for the specific component, cost calculations, lead time calculations, and CO2 footprint calculations. So this basically helps you to quickly identify business cases for additive manufacturing, also just business cases for changing materials, changing to advanced manufacturing technologies. So it means we sort out not printable components, not profitable components, and select the ones that save costs, save lead time, save CO2 emissions, or that comes with increased performance. So how does this work? Want to give you a bit behind the scenes of 3D Spark. There is the manufacturability analysis. This is basically where we analyze the specific components for all the design guidelines for the specific technology material combination that we are looking at. So talking about 3D printing processes, we might check the component for the part size. So does it actually fit into my machine? Does it fit for the specific process? So think about binder jetting. You can only produce small parts. We check for wall thicknesses, gap sizes, support and powder removability. So looking at this component here, for example, there would be a need for many internal support structures that might be hard to remove afterwards. And this is everything done completely automatic in 3D Spark. The second big point is then actually the technology selection. Where we compare 16 different manufacturing technologies, so 13 AM technologies, also against CNC milling, casting and injection molding. How we do that is actually we look at your specific component, then at the technology and material that we are looking at, and we build up the whole process chain that is needed to generate this specific component. So for an AM process, a metal AM process, for example, this would be data preparation, then the main build process. In metal AM, this is normally the biggest cost driver. And then you have a bunch of post-processing steps, like tempering, plate removal, support removal, sandblasting. And on that basis, you can have a very good estimation on what are the actual cost drivers behind this specific component. Is there anything that I can change about it? And this is what we do for all the different technologies and materials that you are looking at. And on that basis, we can then also make a break-even analysis. So, for example, you think about ordering 10 parts a year, then you should stick to additive manufacturing. But if you're going for bigger lot sizes, then there will be a break-even for CNC or casting at some point. Another pretty new feature in 3D Spark is the 2D to 3D feature. This enables you to upload 2D images, so either technical drawings of the components or even just bare images. and we generate 3D files out of it. So we can actually convert your legacy 2D technical drawings into 3D models. And we can also transform pictures into editable CAD geometries. And on that basis, we accelerate the spare part digitization and digital warehouse initiatives. Another thing that I would like to mention is that we are currently working on a collaboration with the Word Additive. So as we have seen, 3D Spark focuses on the very first part in the process, so the part analysis and the identification of business cases. But you don't want to stop there, actually. Normally, you will then go to a digital inventory system like Word Additive, for example, where you then store your identified business cases. You generate the production-ready data, and then on demand, you simply produce locally with no physical stock required and always available. So this is now a combined solution that we can offer together with Word Additive. That's not my face. Actually, I'm replacing Daniel here today, but more than happy if you come for a chat. Yeah, that's it. There.
So welcome, I'm Gregor Eichler, the CEO of Qualified AM, and we qualify AM. Qualification is driven in the AM industry because of two major reasons. One of them is, of course, a scalability to production. So that's a new business case for AM. It's a difference to printing a part, put it on a table and demonstrate what can be done, to do it in series or whenever it's needed, qualified. So that's what we stand for. We develop standards, we develop qualification schemes, we develop software to accelerate the qualification of additive manufacturing processes, equipment, parts, materials, and production lines. So why we can do that? Because we are committed to. So I decided in 2008, actually already, where it's already 18 years ago, with the first experience in dental. And dental was the most serialized process in AM industry. It's still the most successful business case in our industry, and where we produce millions of parts in series, and each of those parts is individual. Because we are all human, we have all individual shapes in our mouth, so it's individual and it's qualified. So we learned a lot from this process, how to do it for all other industries. And this is where we're coming from. So I started in 2008, was a customer of EOS. EOS is one of those market leaders in the industry, which really produce top-notch systems for industrial use, and developed the dental process and for all countries. So we learned how to produce the dental crown in China, in India, in the US, and the European markets with the same quality. This is all done already in the industry, and we know how that works. So that's why we wrote standards for it. ISO ASTM standardization is happening since roughly 15 years. And Germany is actually leading the space as a technical committee of the ISO chair. So the ISO standards in additive manufacturing world, there are already over 50 ISO standards are led by the German DIN standardization. And we are doing that already since 20 years. So nobody needs to say that we are missing standards. There are enough standards. There are more than 50 standards. Of course, we still miss maybe process technology specific details like ceramic printing, maybe some material specific, but in general, we are well equipped. What we miss is the commitment to implement standards. So what we did, or what I did, went to TÜV. TÜV is one of those certification bodies in Germany, and we empowered TÜVs to understand what manufacturing is about testing, what they need to look for if they validate additive manufacturing. Then we basically I opened my company after TÜV because I realized it's a little bit too early for these large organizations, because additive processes are very hands-on, detail, in process control, and TÜV organizations are more on the management level of quality checks. So I opened Qualified AM and we started to offer the service as a startup. And this seems to work. So we are now very successful in medical, rail, and semiconductor industry. And since 2 months, we start in the space industry. So it seems like that was the right choice, because we can qualify on a global level. So we're not regionally limited like many of those TÜV large organizations. They have a regional domain, so they cannot scale abroad, but we can. And we are at each additive manufacturing exhibition, which is size of Formnext and Rapid TCTs. So we promote the qualified solutions to the industry, so everybody sees the difference between qualified and not qualified. In hands-on problem, what we are solving is that qualification was mainly expertise driven. So the companies hired a very high expensive consultant, which worked 20 years in the industry, or a quality manager, and they basically developed qualification in medical or aviation sectors for free till multiple years, and that's very costly. So only large corporates can afford such a expert and such a time to marketing. So we drastically reduced this time through our software, through the standards. That's this time of 3 till multiple years is reduced to months and weeks. And that's very new, actually. We just introduced our software in the last Formnext. So you are basically in a lucky position to know, now AM moves into a new era. We can put a cost of qualification for a business case and have a return of investment calculation, which is very transparent, including the efforts of qualification. So we are opening actually a completely new market, which hopefully is bigger than Alfred showed us. Yeah? So we are looking very optimistic into the future because this was not possible till now. So because qualification was always kind of a huge question mark in the industry. How do we overcome this? Yeah? Everything is basically baked by ISO ASTM standards, and 52920, that's the most important learning for you all. Please take that with you, note it down. That's the most important standard which fits to all applications. Whatever, if you are in medical, aviation, space sector, this standard you can always reference and use for your qualification. It's a publicly available standard, costs €150. Everybody can purchase it. You can reference it. If you buy equipment, ask if they are compliant with the 52920, because this is as well the story where it starts. If we all not together shape the ecosystem and say, I would like to buy a printer and a material combination, but it has to be pre-qualified. That's very important. Otherwise, the companies will never do it by themselves, because they want to sell the dream of manufacturing, and then they will leave the homework to the customers. So that's as well very important learning. We are now empowered to buy qualified printers and qualified equipment. You just need to ask for it and reference the standards. The standard is written in such a way that everybody understands it, actually, who works in AM. Data preparation or data entrance control. You see the manufacturability assessment and review. And that's very good that we did it, because a production line which is offering printing services to the market is forced by this standard to have their customer contact standardized. So they ask the right question. How much validation efforts is needed? What kind of coupons are needed for this part? Would you like to approve it for medical sector? These questions are important at the service provider level, which focuses on the industrial scale manufacturing with AM. And then following the typical operational process, data preparation, in-process control, feedstock management, and post-process for the parts. Of course, that's logical, that's engineering. There are 160 shell requirements in the standards. 160 times you have to have your feedstock under control. How do you transport it into machine? You have to have your defined procedure, how you refresh your feedstock. Yeah, that's logical, that's engineering, that's what we standardized. And it's done. Now we just need to apply. Of course, this is not the only one which is important, but because we all work in regulated segments as well, and each regulated segment has their own domain of standardization. Medical, 13485, automotive segment, they have the standards, space, ESA standards, NASA standards. So everybody has their own idea of certification as well. But what we do, if we certify the 52920 for a customer which comes from a regulated segment, we show the overlap to his existing standards. So basically, if they are in space, we show them, okay, you are 80% conform with the ESA standard ECSS, which is great because once 52920 is certified, you can show conformity to all other regulated segments. And that's exactly scalability in AM, what we need. Nobody can afford to get qualified by each regulated segment. That's too expensive, but we can afford to get qualified that our AM processes are reproducible. And reproducibility is the key word, actually. So that's why we do it, because we all know, at least those people which are hands-on in the process, reproducibility is still sometimes a challenge in AM. And this standard assures reproducibility is covered. One of our customers is ASML. This is the most complex machine in the world, by the way. And this is one of the remaining domains where Europe is still 10 years ahead of China. So ASML's machine are manufacturing semiconductor chips, AI chips, 3 nanometer chips. No machine in the world can manufacture these chips, and we qualify there a supply chain of additive manufacturing spare parts. We are very proud of it because we are just a startup, but they trust us. They say, okay, you have the best qualification program in the world. That's why we basically want you to qualify our supply chain. Deutsche Bahn Railway, we have built up their production site in northern Germany, and as well wrote together the standard, the 52920 representative from Deutsche Bahn. And that's basically a very great case of obsolescence management. Wherever spare parts are needed, we have the qualification program for it to assure reproducibility. Hospitals, UKM, one of the biggest clinics in Germany, prints on demand in hospital different applications. Space, so as I mentioned, ESA is asking us to qualify the first suppliers according to 52920, because they see that European space needs to be scalable as well. We cannot afford the slow progress anymore. We need to hurry up and scale our qualification schemes because things become transferable. So we use the 52920 we proposed that to ESA, and they really liked it, and they asked us to qualify the first providers in space. Yeah, the program looks like that. Customers are asking for qualification. We define the scope based on the AM standards and the regulated industry standards. Then they get our software. The engineers are asked questions, so they don't need to be trained because our software it's very clear standardized, so they just answer questions. And this takes something like 2-3 weeks. And then they developed their documentation in our software, so the quality management documentation, which actually is very standardized. And then they call us, hey, Gregor, we are ready. So we go in, audit, say them, okay, this is your report of conformity. So they clearly know what gaps are still remaining. And if they close the gaps, we go back and issue our certificate. Yeah, and our certificates are right now known as the global brand for qualified AM or reproducible AM. One innovation, last slide, what I would like to show you that we are able now with our software issue part conformity. So all parts which are in regulated segments, which nobody wants to sign off. And we discovered this in the defense industry, on the way, which was an AM Village event in Albacete in Spain this March, where MODs, so operational units, can print a part, but they cannot replace it. So basically, nobody wants to sign off the part that it can be mounted in. So printing is one, but signing off is different. But if we provide a conformity report for a part, that this part is manufactured based on standards, so people sign off and mount it in. So it's a huge enabler. Okay, thank you. Looking forward to discuss in detail. We have a software here. I can demonstrate you. I'll give you a free demo license for the software, so you can get your fingers in and your mindset. And yeah, let's scale. Thank you.
Do we have such a thing? Pointer in? Nein.
Hello. My name is Christian Gerking. I'm from a family-owned business company, and we sell powder and atomizers. Thank you. And as Ignacio said, you have sometimes new designs of steel, new materials, because the thermodynamic is old, maybe 150 years old, but material development always goes on. For example, on a smartphone, the glass is a touchable material. It's a touchable glass, and the revolution with the smartphones would not have happened without this glass. And this is a material issue. So materials always are tested, and we sell powders for new materials because we have small plants, and we can also deliver small quantities, 2 kilograms, 10 kilograms, 100 kilograms. But our kernel point is we have technology. And for example, we also could deliver the third technology for atomizing. So I will explain more in detail what our technology is. So this how our plants look like. So do we have a point? So there's no pointer. So this was one of the first plants. So we have a pressure chamber here in which the crucible is, and we spray into the towers. How different, other than in closed couple atomization, we have the crucible within the pressure chamber, and the gas with the melt flows to the nozzle, and then it expands to droplets. This is a fixed machine. So this is how the process looks like. A pressure chamber with a crucible and a coil for inductive heating. Then we have a plug. We pull the plug like in the bathroom, in the baño, and the melt releases down, and the pressurized gas wants to flows to the nozzle. And if you have a critical ratio of pressure, so if you have, it's a law by thermodynamics that if you have a pressure ratio of roughly 1.8 for the most of the gases, or 2, then you have sonic speed. So we can atomize up to 25 bar, and the gas will approach sonic speed, and the gas gets a very high momentum. The gas has a high momentum, and the melt gets a high momentum from the gas. And yes, so what is the point? The point in our process is that we have a higher momentum transfer from the gas to the melt, and we consume roughly 50% of the gas compared to other processes, compared to closed couple, for example. And if we consume more gas, we can approach regions where we have even below 10 micron a reasonable yield. So we can reach smaller particles than all other processes we know. And for standard material sizes, we have a smaller gas consumption. So this is a diagram giving ideas about the gas consumption. I would not. So this slide shows that we are experts in powder manufacturing, because my father founded this company roughly 40 years ago, and he wanted to sell the plants, but unfortunately we did not find someone who wanted to invest in a big plant. So people said, why don't we? At this time, the 3D printing was not invented, or it just 1986. It was just invented 1 year before in America, but he didn't know. My father didn't know it. he came from the textile industry, so it was nice for me to hear that this is the textile region. And this shows that you have to deal with the details. So if you want to have a certain flowability, you need to know how can I classify, how do I manufacture the powder precisely, so that the obstacles are not the 10 or 12 micron. The obstacles are the very small particles like 4 micron, 5, 6 micron, and so on. And you have to classify them out, and then the flowability is higher. But this, we don't have so much time. This only shows that the curves have to be scrutinized in detail. We have here, for example, 2 lines. So one is the nanoval powder. This is the blue one. And the red one is another powder from the market. And both are classified. So we assume, this is just a mathematical issue here. Both are assumed to be classified higher than 8. So all the particles smaller than 7 are out. And all the particles larger than 37 are also out. And you see the dotted lines are the atomized lines, so they're different. So we have a very narrow particle size distribution. I forgot to tell you. So we have not only the very small particles, we have also a high yield because of the very narrow particle size distribution. And so these are the origin curves, the blue one from us and the red one from the market. And if you classify them like the hairs, which is not possible in reality, we know in the classifier, it's always, or in the screen, it's always a statistic. So you cannot exactly cut the smaller particles out. You have always some particles which are in the process, although you want to have the particles over 8 micron. The normal lines are totally different. So the red line and the blue line are so-called the same, but they're totally different. And that's what we know since nearly 40 years. We have done more than 1,500 alloys, gold, platinum, magnesium, aluminium, tungsten, niobium. So we have done very many alloys for all over the world, jewelry industry, aviation, medicine, automotive, of course, and many of the universities, Fraunhofer institutes, who want to have some powder from their new alloys. I always say the Iranian population between 50 and 45 is different to the European population between 15 and 45. 50 and 45 are the standard classifications of the powder in 3D printing. And the example is not so accurate. But the population of the powder is this year, and they have to be assessed. You cannot classify the powder only by 2 parameters. It's not possible. You have to make trials. That's what Gregor also said. You have to make the sample to confirm it, so that you know what you get. So the input material has to be assessed very detailed. Okay, we have a very spherical powder, and we have a good flowability. We go through. We can go down to 5 micron. Some customers even want to have powder less than 5 micron, but then even for us, the yield is not very high. Some years ago, we developed the crucible-free process for our nozzle. So we have a special nozzle, and there was already on the market a crucible-free process. And we combined these 2 processes. We thought this is a good idea. And now we can also atomize materials which cannot be molten in a crucible because they react. For example, if you put titanium in a crucible, either it gets the carbon or it gets the oxide from the zirconium or aluminum oxide. So it is destroyed. It has then more than 2000 ppm of oxygen, and then you cannot take titanium. So some materials, or tungsten, melts at 3000 boiler degrees. Some materials you cannot melt in a crucible because the crucible cannot be at the temperature, or they will dissolve the crucible. My father came from the nonwoven industry, and he earned his money with plastic in China, so with the chemical reactors for polypropylene, for polyester. And we have also developed the same technology, the same nozzle idea for polymers and cellulose according to the lyocell process. It's just by chance, just to introduce ourselves. So a lot of his money, he said, so you have your study, you get some, when I die, you will get something, but I will put my money in this company and I want to build up something. And this is the spin beam. He ran out of money. So if you know someone in Spain, Catalonia, who wants to work with a spin beam, tell me. We want to give this technology in good hands. We made some calculations. So these are 4 rows of multiple spin jets. And you see it's very complicated. So our nonwovens, for example, for fem hygiene, for ductless, for face mask, if it's a cellulose, it has to be absolutely optical perfect. So nobody wants to have a diaper on which are dots or lighter regions. It has to be absolutely uniform because in the textile industry, everything is optical on a high standard. So this was our point, which we did not reach. So this is a founder. This is a titanium yield, 25% lower than 25 micron. And these are some metallic glasses, tungsten, and so on. And if you like to talk to me later, I have some cards, and then we can make an offer for you. Buy some powder from us, and also a class if you like.
Yeah.
Thank you so much. So, coming to the panel discussion now, I thought we still have some time, like 10 to 15 minutes, I guess, even if some of you were far out of time. So I think I would just start with the ones that kept the time. And I do have the first question for Fritz. You talked as well about the digital inventories. And I know as well from the rail OEMs that we have on board and that you work with, we're gaining traction in that field, especially with new hardwares, and as well it's getting into tenders in some industries. So what from your point of view, talking to the potential customers, what are the biggest barriers that the companies face from going from that physical spare part models to really going into digital warehouses?
So one point is definitely the identification of the right business cases. So first of all, you have to know which components are actually 3D printable. Oftentimes, those are companies with huge portfolios of components of parts that they have in their current warehouses. So we talk to customers with more than 1 million unique components that they manufacture a year. And for that, you have to make this assessment. Is this actually a 3D printable component? Do I have to add specific certifications? How much will it cost? Will a certification process in the end kill my business case, for example? So those are all things that you have to consider when going from a physical warehouse to a digital warehouse. And then you also need a digital solution to actually handle your digital warehouse. So again, that's not our part, but we have a good partner we're working with. So I think those are the two big challenges. One is the making the right decisions, identifying the right business cases to actually do it. And the other one is to select the right infrastructure to do it. And this is on the one side, this is the software part of it. And on the other side is also having the network of the right suppliers, right? So there are, Alstom is a good example. They have their own manufacturing hubs, but the they also not spread across the whole world, and they also need additional external suppliers to be really in the position that you can have this on-demand manufacturability for your spare parts. So I think those are the two challenges.
Yeah.
Any question for the second one that did take the 10 minutes? Seb, you just told us a lot about Wooly, or is it called Wooly or Belly or Boiling? Okay. But that's just one of your customers, right? So in which field is the expertise of Technocampus? Is it regarding like just a bigger group customers and industries, or is it a very general approach?
Okay, first of all, I want to say we don't have customers, we have users, because we don't make any money on that. But I would say that, of course, we have many visits. We have many days like today where a lot of companies approach us, and I would say that we have many different users from, as I said, small companies, car workshops, packaging companies, chemical companies. So I would say that anyone that wants to materialize an idea, it could work with us. I want to think about very like special things, but I don't know. Yeah, we have many different ways, because as I said, if you look or if you listen to them, or of course we visit them, because when you visit with your kind of additive manufacturing thinking, you see a lot of cases where you can maybe do a part different, or you can add some special functionality to something. So yeah, I would say that anyone that approaches us, we may think of some case to apply additive manufacturing.
Very interesting, because like in the network we do have the same view on that, right? It's about the user always in the focus, and we are not selling things as well, but we are always trying to push users into having an own team or own capacities to really understand additive manufacturing, right? And not just outsourcing the production. And I think it's always about the size of the company, and as well the interest and the potential of AM for the industry, right? To go into. Just speaking about that, Hans-Alfred, you were part of like writing the change management booklet, where it's exactly about that. What are your experiences over the last years? Exactly for that, like when is a customer or like a company the right one to get into an own team of additive manufacturing, or when do you are you more likely to just hand them over to like the right persons in the industry?
Well, I think it also depends from the economic situation. Right now, we are cost cutting and saving money. There is not much capacity for new mindset in AM. That's a problem, I would say, because we need some more open-mindedness in AM thinking. So, we need some CEOs who are really interested in changing their mindsets. If you must start top down, you cannot put up AM from the bottom in a company. That's not possible, because there are also the people are sometimes nervous when they are really responsible for the products, that because if they get it from a supplier, that they have no responsibility. It works to the supplier is in charge of that. But if you print it in-house, that you must have more an entrepreneurial thinking, that you are responsible and that you really like to promote AM in the company. And that's the reason why you have to start it from the top.
Perfect. just giving that back, because it was as well not the most positive outlook. As well, what you gave us there was like the fear of China and stuff. So I really wanted to ask you after that presentation, like where do you see the hope for our European industry? Because that was quite pessimistic. And I think there are a lot of good things as well that we have in the European industry.
Oh no, I think we must be more open-minded to really defend our market situation. So I think the defense question will help us to become more important because defense is more European-minded thing. So and we also should more open to the, I do not say danger, but not to open too much doors to the Chinese competitors. So should be more focused what we have here and how we can give.
So, and I think it's as well something that is driven a lot by staying innovative, staying ahead, like trying to remain that gap between Europe and China. And I think like in institutes and like yours and technology centers and are like the main drivers for that, right? So maybe as well from your expertise, where are we far ahead, or what are the fields where you see that Spain, for maybe as well Europe, is far ahead, and where's the biggest potential to stay very innovative?
Just taking the advantage of the mention to China, they have a very aggressive strategy on IP and knowledge, because they publish a lot, they patent a lot. So if us, that our day basis is to read papers, to have new ideas, to think to new projects, you search for a very specific topic that you imagine that has never crossed to any mind, and there's a Chinese scientific who has already published. So this is a great example of as the country having a strategy on IP and on knowledge generation, how can impact to the society and to markets as additive manufacturing in this case. So maybe we can reflect on that and change a little bit our minds also. So all the companies can do research and focus to the market. It doesn't need to be a very basic research that the universities already are doing.
Okay. So do you see more industrial projects for your side in regulated industries, or coming from non-regulated or low-regulated industries?
There's both, but also, as I said, we work a lot with small and medium companies. Most of them are not from very high regulated environments. So most of the applications and the projects we have are non-regulated environments, but some of them there are. But we work in proof of concept and industrializations. We never get to certification. Maybe our value is more on generating process understanding, material understanding, generating, as I said, new methods for testing materials, not on the proper certification that there are other companies who are doing great jobs.
Yeah. So Gregor, what's your point on that? Because you are always preaching, and just try to be provocative now. You're always preaching we need like to use all the standards. We don't need even more standards, maybe some, but just as well using the existing ones. I see that pushing more applications into the regulated industries like rail, like aerospace and so on, where you do have regulations, but especially in Germany, we always talk about like our backbone, which is the Mittelstand. And for them, another qualification next to the 9001 is always like holding them from getting into that. So looking into that big potential of a mass production as well with AM next to the traditional industries. What's your comment on that? Like how to serve them with not too many qualifications.
So first of all, I believe that what we deliver to the market, it's absolutely aligned with the existing certification. So we don't duplicate anything.
Yes.
So that it's not what Qualified AM provides is just full transparency how they overlap to existing standards. 9001, 9100, 355, automotive, ESA space. There's always overlap. But our focus is on that what we need to do, our homework, and that's reproducible production processes. That's our homework, what every needs to do in our industry. Otherwise, we will never come to a valid business case and a functioning production line to which is trustful and empowers a new business cases. And the new business cases, I believe, for Europe are for sure something like cooking recipes. Yeah, cooking recipes to print a part or production like dental was done, like hearing aids were done. Spare parts in regulated industries are done. This becomes possible with such a standards because we can clearly say if you print this part, you need to have this feedstock, this test body. And this procedure installed, then it's going to be reproducible. And here I see as well the advantage, because we are regulation masters. Europe is regulation master in many domains. And if additive needs such a strong regulation, what is obviously because it's complex. It's a complex process. It needs regulation. Why not to turn it into an advantage? It has to be an IP advantage. That we know how to print a part and we have the cooking recipe and maybe even patented specific material combinations or specific parameters for this particular part. There is the IP of the future for Europe because we have the regulation mindset. We understand how to regulate. We don't copy others like other countries do. We invent our own. But this requires commitment to our homework. Reproducible AI. Yeah, that's it.
Question, maybe one last question before we're running out of time, especially in the side direction. You showed us the curves, right? And as well talking about institutes and so on coming to you with like new formulations to test them. Do you see a problem then afterwards switching from your smaller amounts to them maybe going into other production processes for the very big scale, getting other curves, other
No issues. When they buy a plant from us, they get the same curves. Of course, if we sell the plants, and we help them to build up their business because we know how to run a screen and a classifier, and we deal with the powder every day. So we are not an engineering office only.
Is this the normal way that the customers of UK is that they
all first the powder and then they develop their ideas and then they needed more powder. So we had customers who bought 10 tons a year, other buy every 3 months 10 kilograms and so. Yeah.
Okay. Thank you very much. So then I think we are ready for the first break.
The second round or second table runs on behalf of Josep Gomez from Techno Campus.
So, well, I think you're in the best hands you can be. So the floor is yours.
Thank you so much, Marcus. Also, very warm welcome to everyone here to Mataró. Well, these tables will showcase advanced manufacturing technologies applied across different sectors: aeronautical, naval industry, defense sector, in real life situations. So we will try to do it in a very practical way. Also the presentation, so you can understand better. We're trying to transmit all the information in a very. So for this, we will have a great table with experts and with great experts. First, we have Marc Garnacho. Marc Garnacho from the company Engine Hub. This is an engineering company specialized in 3D manufacturing. They are very focused in the first supply chain of the sector. Then we have Carlos Costa. Carlos Costa is project manager from Hyperion. Hyperion is a multinational company based in the United States. And they are developing advanced hard materials, tooling solutions, and wear-resistant technologies. We also have the company, Mr. Patrick Consul, from the company Lean Technologies GmbH. This company is developing production-grade extrusion additive manufacturing systems and using advanced local thermal control and industrial automatization integration. Then we have Adam Rumja from the company Orion Additive Manufacturing GmbH. Is specialized in additive manufacturing system for high-performance polymers and targeting sectors like aerospace, defense, and medical technology. Then we have Michael Kolbesha from the company Top Model Fabrik. It's an engineering and manufacturing company focused on lightweight components and 3D printing solutions and customized industrial product development services. And last but not least, we have CTC GmbH, Mark Maya. This is an Airbus technology subsidiary specialized in lightweight structures, advanced manufacturing process, and innovative, of course, aerospace production technology. So we will start with Mark. Mark, the floor is yours. Thank you so much.
Okay, so hi, and thanks to invite me here to speak in front of you. I think that maybe I'm one of the smallest business here because it's just only me. But I have a wide range of experience in 3D printing, especially FDM, but other technologies too. Enginum, it's a mix of engineering and humanity. So it's not only 3D printing, it's 3D printing with the vision of the 5.0 technology, which means put the person in the center, sustainability and resilience, which I think that Paisor who speaks before, it's just the center of all the things. I am centered mainly in two focus. A small, really small business. In Catalonia, especially, the huge amount of business are really, really small. And I speak a small about less than 10 persons, but they have an income about millions of euros. So I'm trying to be specialized in this kind of sector. This kind of sector has a particularity that is they work with public funds, with Eurecat, Leitat, Thinking, with institutions like that. But then when they have to implement 3D printing technology in-house, they have a really big problem. And that's where I personally enter them. So the thing is that they know in a paper how to do the things, but they don't have the capabilities to do. And it goes always to the same point. It's not money, it's talent and time. So another point of my business is to train this talent. Not only in business, huge business, it's easy to train people because there's people, but in a small business, they always are searching talent. And this is where I also train people in 3D printing. So small business in Catalonia, some of them want to use 3D printing, but it's also true that when you go to that business, there's a fast, it's 3D printing. I don't know in Germany, but here in Catalonia, when you go to visit them, there's always a big problem that is 3-4 years ago, they said I could do everything with 3D printing. I tested 3D printing does not work for everything. And yeah, that's true. 3D printing does not work for everything. And this is what we have to also break this myth and work with them, applying 3D printing in their processes. And well, that's mainly my work, advisor for technology, also training in business and for students, and yeah, implement 3D printing technology inside the business. Not only outsource all the processes, implement 3D printing inside the companies. I'll try to make it slow and concrete. Okay.
Okay, hello. I will introduce myself. I am Carlos Costa, project manager and also production manager in Hybrid Materials. We are a multinational. I will not speak a lot about 3D printing. We are new on that. But for us, it's an important challenge for the future because we see a lot of opportunities, and you will see here a lot of opportunities in our company. But we have our company is special because we work only with tungsten carbide and all these kind of materials. So it's like artificial diamond. So we are, and then you will see that in this case, we are trying to use 3D printing for the future. So as you see, our business consists in working with this. So for us, our core business is to also to have this knowledge in-house, also to keep that knowledge in-house for the material. This is also a key for the future, also for the 3D printing and the additive manufacturing technology, because we want to keep all this knowledge from the beginning to the end. So we develop new grades of tungsten carbide powder in different factories in US and also in France. And then we do engineering support to the companies to find solutions for their applications. There are several sectors that are very used to produce with tools made of carbide, okay? But there are other sectors that we are new. We have to convince the people to change from other materials to carbide, okay? So this is one of our keys in our business. And finally, we produce them in a lot of factories we have around the world. Okay? So as we said, we will see that we are in a lot of sectors, and there are sectors that use normally carbide, okay, tungsten carbide. For example, the beverage canning. The beverage canning, you have to imagine that we produce over 50 in the world. They are produced over 50,000 million, so 50 American billion cans every year in the world in aluminum cans. So to produce that with this kind of cans, that if you look you need very precise tools, and these precise tools are made by tungsten carbide. So the customers, this market is also mature. So the customers know that to produce better than they need carbide tungsten tools. But there are other sectors, for example, the mills, to produce the steel in the steel mills to transform the steel in the mills. Normally, they are using other tools, for instance, tools of, also of steel, for example, not to produce. But if you want to change that, okay, you have to convince them to change from one tool that they have to spend 50,000 euros to one tool that they have to spend 100,000 euros. So it's very difficult for us to enter this kind of markets, but we are entering in this kind of markets. How? Convincing more. There are a lot of times that the people that we have to convince is not the procurement department or the purchasing department. We have to convince the production manager or the maintenance manager in order to say, okay, you will change this tool, but on the other hand, you will gain in reliability, you will gain in quality, you will gain in all these kind of things. Okay, so for us, it's very important to keep all these business that are very clear, are very mature, but only to enter in other business. Okay, So we are a company based in Worthington, in Ohio, in US. The invoice is more than $500 million, and the number of employees is 2,100, more than 2,100. We are sales in 26 countries, and we have 70 manufacturing facilities around the world, in North America, Europe, and Asia. Okay, so a lot of people knows about that because we were Sandvik in the past. Sandvik, a Swedish company, and part of Sandvik, this part especially was was bought by the group KKR in 2019, and then from that date we are Hyperion Materials and Technologies. Okay, so luckily one of these manufacturing facilities is located here in Barcelona. Okay, probably the biggest one. Okay, and there we have already our R&D development center for all the world. Okay, this is why we are trying to develop all this kind of technology. We invested 5 years ago. We invested also in this kind of technology and 3D printing and in this kind of technology to supply all these sectors. We work with aerospace, with automotive, with electronics, with food and beverage, with general manufacturing, hygiene, medical, oil and gas, and steel production, as I said before. Okay? So we are around the world also, in EMEA, also America, and so on. And our main challenge here is to keep that knot. So we want to develop our own raw material. Okay, we are doing tests on that. So we are working two things here. First, we are trying to have the capabilities in the machines that we have invested on, and the other main point that we want to keep is to keep the knowledge of also the product, the raw material. We want to keep that in-house. Okay, so this is why we are developing. Even though, if you know, our material is the tungsten, and the last year has multiplied per 10 the price around the world. So, okay, due to all the commercial issues we have around the world, and this is why we are so proud to keep that knowledge inside. So we cannot use the same raw material that we use in the normal process. We have to use that material, but also transforming that in the material that we can use in this technology. So this is our key point for the next years. We are developing this process, and also we are in contact with several customers and potential customers for the future in automotive and others. Okay, so more or less my presentation is that. Thank you for your attendance and attention. Thank you.
Yeah, thanks for having me. My name is Patrick. I'm one of the founders of Lean. We work in large format extrusion AM, so pallet extrusion, usually on robotic systems. But we don't build entire printers. Just to clarify that from the start, we make this ring that's down here, and that then gets mounted onto existing platforms. And what we do is we do localized thermal management, which basically means that we weld the layers together to get higher mechanical strength and faster processing, and more importantly, more stable processing. Extrusion AM, like any other AM technology, offers a lot of benefits to manufacturing supply chains, to de-risk. If you have localized production, you have basically lot size 1, and you can leverage a lot of this, but it's not really transitioned into industrial production because there's several adoption barriers that were preventing this from happening. The most important one is that material strength and performance just isn't really that reliable, especially if you move to larger parts and to high performance polymers. And a lot of these problems are actually linked to the thermal conditions as the layers are being applied. The material needs to weld together layer by layer as it's being built. At the same time, it needs to cool down and solidify it to be actually built layer by layer. If it's too hot, it will just collapse on its own. So you typically have this joint problem that it has to be cold to be solid and hot to weld together. And we try to separate this problem into having a hot surface that we melt with radiation. We heat it very locally, very quickly, while keeping the rest of the material below stable and cold, separating the problem into two issues that we can control separately by cooling most of the part and heating the surfaces that we need to heat to weld the layers together. So we usually start with an existing extrusion platform, so you'll see a lot of seat machines in these pictures, and upgrade it by adding something on the extrusion tool, as well as some control intelligence in the back and the control cabinet, which is our retrofittable module. And basically what it does is it senses in real time what the surface temperature of your part is just before the nozzle, measuring two things at the same time. Once very far ahead on the toolpath to see if the part has stabilized and is cold and it's ready for the next layer, and very close to the nozzle where it uses light to reheat the surface and weld the layers together. All of it is in a closed loop control. So even though temperature is so important to quality, most of the printers don't measure it at all. For us, you get a closed loop control. It regulates the machine speed, the cooling, the heating, all of it on its own. And in the end, it logs all of these process data. So hopefully we make the job for people like Gregor easier by giving them a digital twin of a point cloud of all the manufacturing data that they can then use to qualify the part. So it's a very large machine, and you're probably wondering, what do you print with large machines? The answer is large parts. And we find large parts in these 6 sectors. The first 3 are where we see short-term commercial potential or already are in serial production. The first one is maritime. Boats are big, usually. That's actually our newest use case since about 1.5 months ago. They print boat hulls of 12 meters in length, and one layer, if you go around the boat twice, has a total layer length of over 40 meters. So it's just part size that makes this difficult to print because your layers cool down so far. So the benefit that we offer here is that you can print longer layers without sacrificing mechanical performance. Oil and gas is actually an interesting one. It's the one that has accompanied us from the start. So we print seals for LNG platforms and gas exploration ships. It's a really boring part because it's just round. But they start from 700 millimeters in diameter and they go all the way up to 4.5 meters. And they print mostly in PEEK. And the interesting part here is we actually managed to match their material specification from compression molding with the same material that they use in compression molding. So we're not redesigning a completely new part. We're replacing a legacy manufacturing process with 3D printing, bringing all the supply chain benefits to this part, which basically means that you have lower inventory for parts that are critical infrastructure. And then, composite molds are pretty well known for large format. The other 3, aerospace, rail, and automotive, we're seeing mostly at university level still. So it's R&D mostly. A lot of it is overprinting thermoplastic composites to functionalize parts. Basically managing obsolete spares in long lifetimes and consolidating sub-assembly groups into individual parts for weight savings. So that's one of the boats that one of our customers, Impact, is printing. You can kind of tell how big the boat is. I think this was roughly halfway through the print, so it's around 6 meters at this time. And basically the 6 important parts for them is that it's completely controlled. So you have changes in cross section as the boat transitions through its different shapes. You have all these dividers in between, and the process automatically adjusts. So you don't have any overheating, you don't have any undercooling, and it continuously heats it. So you get the same mechanical properties along the entire length of the boat. You log all of the thermal data, so you can make sure afterwards you don't have to trust those. And we're trying to work with them to use this data in the future in terms of regulatory frameworks and standardization. To basically be able to test the data rather than to have to do a drop test on a boat like this. One thing I missed before, safer operation. The normal way to preheat something would be a laser. We don't use a laser, we use LEDs, which sounds a little weird at first. But it gets you the same responsiveness as a laser, so you can adjust power very dynamically and respond very quickly to changing conditions that you have in 3D printing. At the same time, it's a broad spectrum emitter, which is safer to the human eye, meaning you don't need enclosed laser safety cells. You have the same safety requirements as you do for wire arc welding, actually even less than that because we have no UV content, meaning that for very large parts, it's much easier to get this integrated into a production environment and approved by working health safety for use in production environments. The way we typically work is that we start from one application. So typically we don't do cubes unless you specifically want to know if it's a material, if it works with a specific material. Normally we start with a part, for example, with a seal. Ideally it's a real part, so something where you already know what the requirements are in real use cases. So we know what we have to match. Ideally it's a part that is causing trouble in production, either because it's low volume, large parts, or inefficient manufacturing processes where AM could benefit your supply chain a lot. We work together with the end customers usually to qualify this part. So initially we print a part for you to test, see if it works. If that convinces you, you can try it for a short amount of time. And if that really convinces you, then you can buy the machine in the end. So it's you don't have to trust us. First, we can prove that we can actually deliver on what we promise. So yeah, that's it from my part. Be happy to discuss any parts or explain more if you're interested. Thanks for having me.
Hi, everyone. I just want to thank everyone for having us here today in Mataró. It's a pleasure to be here. So my name is Aran Ramjan, and I'm representing Orion Additive Manufacturing. So we developed additive manufacturing solutions for printing with high-performance polymers. So just a quick overview, these are some of our machines. So you'll see here on the left, our largest industrial machine. And the one in the middle is our medical machine. So we're also using this to print implants. And the last one on the right is the first machine we came out with, which is for printing with high-performance polymers. So all of them use the same functioning principle. So what did we do that was special other than just making another FDM printer? So as many of you know, and also as Patrick just explained, one of the biggest problems that plagues 3D printing is that the interlayer bonding is not sufficient. So we developed a similar technology with some differences. So we use thermal radiation heating. And by doing so, we're able to achieve basically injection molded strength. So we do this in two different methods. So we have a chamber, and that preheats the material. And then we have a layer heater that just heats up the uppermost layer. So you can see on the image on the bottom right here, when we use thermal radiation heating, we have very homogeneous structures. It's fully dense and really good fusion between the lines and the layers. And as soon as we turn it off, you can see in that section that's highlighted in blue, you get cold joints and you start to introduce porosity. So the layers and the lines are not really well bonded together. So by using this thermal radiation heating, we're able to achieve much higher interlayer bonding. In fact, we can get all the way up to injection molded strength. And that really opens up a lot of the applications that were not possible before, because the Z strength is always basically the limitation. And engineers are always designing parts according to the Z strength, because that's your weakest link. So here you can see, I actually brought one of these boxes here. We were asked by a company that makes PEEK material. So we specialize a lot in PEEK, by the way. PEEK is one of the strongest plastics in the world. And when you start printing with PEEK, your Z strength is normally as low as 10 megapascals. We printed these specimens by printing these boxes and extracting one of the tensile test specimens out. And so this is a vertically printed part. You can actually see all the layers and lines if you come up closely and see this. But you can see it beginning to neck in the middle. So this is behaving like an injection molded part. And we tested this and we got 97 megapascals. So just for reference, the injection molded strength of PEEK is 90 megapascals. So when we first started telling people what we achieved here, experts in the industry, experts in PEEK told us, this is impossible. you guys are lying. You made up these results. So we said, okay, we're going to contact every single PEEK supplier. Solvay, which is now Science Co., Evonik, Victrex, they all sent us their materials. We printed all of the specimens, and then we sent them back the specimens so that they could do the testing. And the results were basically fairly consistent. You can see the main issue with anisotropy, which is meaning the mechanical properties in every different direction are not the same. This is now something that we've been able to resolve. These dashed lines here represent the injection molded strength. And you can see it doesn't matter which material we use, we basically get injection molded strength or even higher, even in the Z orientation, which is normally the weakest. And we also tested this with other PEEK materials, such as compounded PEEK from Lehman & Voss. With the Ketaspire PEEK CF, this is with carbon fiber, so you inherently have anisotropy. It's always stronger in the orientation of the fiber. But what's really interesting, if you look at the Z strength here, this is where you don't have the benefit of the fiber. But what we achieved there was 90 megapascals in 90 megapascals tensile strength, which is the same as the injection molded strength, more or less, of the matrix material. So you're really bonding that material together. You can just matrix it. These are implant grades, so you can actually produce implants that PEEK is commonly used as an alternative to titanium. And then now we started testing other materials as well. So we started with PEEK, but then we realized, okay, we can do PAEK materials, we can do PPSU, and all the way down to Ultim 9085, which is commonly used in aerospace and in the train industry. And even with ABS. But we mostly focus on these high performance polymers because this is where the real value is. So taking a look at the porosity, this is also really important when you're looking at the tensile strength. If you have porosity or holes or pores on the inside of your parts, this is when you will experience early failures and fractures, because they're basically a source of stress concentrations. So this is natural PEEK, flat printed, vertically printed. This is PEEK carbon fiber, flat printed, vertically printed, which is our worst case. And this was a study done by the Technical University of Warsaw. And what they found was the average void content between all of these specimens was less than 0.05%, so virtually 100% dense. And then they benchmarked this and compared it to some other competing technologies in the market. So you can see what kind of density you can normally expect from other technologies compared to ours. All right, so we worked with a company in Italy. They also wanted to test this, but for real-life applications, just to see what the porosity and what the pressure of these printed parts could hold. So they used a competing technology, and then they asked us to print the same specimen. And they tested from 1 bar, and at 1 bar, you can already see bubbles coming out of their specimen that they printed. And they increased it all the way up to 2.5 bar, and then they said, we have to stop here because if we go higher and once it actually breaks, it could be dangerous. So we don't know how high we can go, but we already did a validation. We can go up to 2.5 bars, which is pretty good for a lot of different use cases. So we have worked with top tier motorsport companies and been able to print parts that required complex fluid control at high pressure. And this has also held up in end use applications. So it's strong enough for space. So aerospace is one of our main industries that we focus on. PEEK is commonly used to replace metals because it's basically chemically inert. You can put it in gasoline and it does not dissolve. So we've used this on a couple of different applications where we're replacing aluminum or even titanium, and with all the added benefits of additive manufacturing, such as reducing the number of parts, integrating many features. It's also great for demisable structures. So in space, when you launch something into space and it comes back into atmosphere, it has to burn up, hopefully, before it comes back into Earth. And PEEK is great for that, so that you don't have large aluminum pieces crashing into onto Earth. So these are some examples of applications that we've worked on. This is an ion propulsion system developed by a company in the US that required high temperature, low porosity parts for being in thermal vacuum. We've developed primary structures for KIFSADs. They can also be metallized. And we've also built battery packs. This is a material developed by IGUS. It's a tribologic material. So they're used to making products that are like bushings, dry bearings, and as well as lead screw nuts. So we're able to print their materials so well that they actually purchased our machine. So if you order parts from IGUS, it's actually printed using our machine. This was a happy accident. It was basically a part that we printed and we broke it by accident. And what was interesting, this was printed in Ultim 1010. And we were kind of thinking maybe it would delaminate, but you can see when it fractured, it broke like an injection molded part. So I'd be curious to also see the tensile strength that we're achieving with Ultim 1010. We were also trusted by the European Space Agency to print a material that they had developed and wanted to test on the lunar surface. So we actually have some of the first 3 printed parts on the moon. Unfortunately, the mission wasn't successful. The lander had crashed. So we have the first 3 printed parts on the moon scattered across the surface somewhere. But yeah, it was interesting. So as I mentioned earlier, PEEK is also used commonly to replace titanium. It is a biocompatible material, and so most implants are either titanium or PEEK. There are other materials, but primarily titanium or PEEK. And it's a really interesting use case for using PEEK for implants because in many cases it's actually better than titanium, especially in cases where you have temperate climate, it gets cold. If you have a titanium implant in your head, you actually suffer from headaches because it gets cold and then it causes But titanium can also release titanium oxide into your bloodstream, which is basically toxic. So PEEK being inert and biocompatible doesn't cause that. So there are many different applications. Some that I think are the most prominent are craniomaxillofacial plates, so anything on your head. So this is one of the, I guess, most prominent applications because it's you basically only create one. You're never going to mass produce these. So another application I think is really interesting is spinal cages. So typically these are small, medium, large, but you can now customize these and basically integrate a whole bunch of features into one. And in some cases, you actually do want porosity because the porosity actually helps with osseointegration. That's integrating the bone into the implant. Okay, so we also tested some PPSU. We don't have the most advanced lab in our company, so we just use a hammer. This was printed vertically, and you can see we could not break this even with a hammer. So other applications, we also printed with PEI or Ultim 985. This is commonly used in railway. Passes flame, smoke, and toxicity requirements. We did a validation with AM Power. They're a consulting company. So we compared this with Stratasys. In XY, we're increasing the tensile strength a little bit, but Z-axis is vertical. So we increased the strength by about 65%. And what's even more important is looking at elongation. So the elongation, if you're using the Stratasys machine, Z-axis is about 1.9% elongation. So we got as high of elongation, 7%, almost as high as in the XY. So you have much more uniform properties, and this opens up a lot more applications than what you can do when using Ultim 985. We've done some research printing with continuous carbon fiber, comparing this to Markforged. When we don't use thermal radiation heating, we get a very similar tensile strength. When we do use it, we increase from 850 megapascals to 1,261, over 400 megapascals increase. So we're really consolidating the fiber and the matrix material together to get a true composite. And that led us to apply for some further funding to further develop this continuous carbon fiber printing with PEEK. You can see here we're printing deployable solar arrays with continuous carbon fiber embedded inside of it. And we're also printing with this interesting material called PEEK LDS. It's a material that you can structure with a laser. You basically laser process it. And then you can put it through an electroplating process and make printed circuits, embedded printed circuits on a 3D surface. So the bottom here is just showing some examples of shape memory effects that we've also played around with, but there's a lot of interesting things that you can do with PEEK. So that's us in a nutshell. I just want to do one quick demonstration for you just so that you can see. So a lot of people maybe want to see it to believe it. So just taking one of these tensile advanced bars, hopefully this was milled properly, but just to bend it. If you bend a part normally, it would just kind of snap at this point, but with ours, you can really bend it all the way. So yeah, you have really good interlayer bonding, injection molded strength, basically. So if you want to come learn more, please come find me. También hablo español, si quieren hablar conmigo en español. Quien pueda. Muchas gracias, Nick.
So after these two impressive presentations, things getting a little bit more normal. My name is Michael. I'm the founder of Topmodellfabrik. We're a German service bureau for industrial things. We're located in the very south, so we're close to also Switzerland and Austria, but we're delivering all over the world. We do full service things. So if you have an idea, if you have not too much capacity, we do everything. We have the machines, we have the post-processing. We work in various industries, and we're quite young. Our team is, we are 10 people, and they're always up to anything what is about 3D printing. You guys know a lot of about 3D printing, so I'm not telling you anything quite new, but the main message I like to deliver in these kind of presentations is that from our side, additive manufacturing is no longer a vision. We keep that in our logo. We shape your vision. So we try to really use it. We use what we have, and we try to get perfect parts. Gartner is a consulting company, and they open up the hype cycle, technology hype cycle. So if you're up into stock market and trading, it's a very good thing to look out what is nice technology within the next years. And since 2016, Gartner says AM is on the plateau of productivity, so you can use it. Don't get me wrong, there are beautiful things upcoming in the next years, but regarding normal industry parts, you can really use additive manufacturing very well. All the buzzwords we have there, you have many possibilities in 3D printing, and we just try to help companies to use it and to get really a profit out of it. Oh, sorry. How do we do that? More or less, we start with a CAD file. We start with an idea. We do 3D scanning. We do generative design, pushing it through the printers. And the very important thing is the post-processing from our point of view. So we do vapor smoothing. We do mounting things together. We do a lot with inserts. And we talk to our customers a lot to have really a good part in the end. We do also like a small series, like 200 parts, 500 parts. We do everything what the customer needs. Also, we in the southern part of Germany, it's said that people are trying to save money, and we also try to save a lot of money for our customers. So we try to offer a good price. Since you guys know many things, I just want to give our view on some potentials. I mean, you know a lot about functional integration. I think this is the key thing of user using additive manufacturing, because many times customers coming with an idea, but the idea is just from purchasing department, like to getting the parts cheaper. From our point of view, it starts in construction, in just having the idea of some parts and begin in the life cycle in the beginning and not at the end. So if you can save many parts, if you can save assembly time, if you can save weight, it's very, very nice. And this is, from our point of view, the best potential you can really use. Also the surface quality, this is what we are very strong in, because if you want to take the parts and really take it to the end market customer, it's really important that you have very good services. And many parts think about the printing process itself, but not about the surfaces. And we try to make it more easy to have these surfaces ready for end use. And especially the vapor smoothing is a very big topic, but also boring, grinding or painting is very, very important for our parts. industrial applications. We have many of them. We have a widespread view here in the audience, I would say. Our company is mainly driven by mechanical parts, by automation parts, by laboratory science. We build a prototype. We also build the series, like I said before. And we have some small customers. They just don't have the machine. But we also have the bigger companies. Sometimes they're not in the mood to do it on their own. So we just search the projects and be there if someone needs parts or has anything to do. Another big message I want to share with you is the big thing about make or buy. I mean, having the machine is one thing, but using the machine, how you should do it, is the other thing. And I would say many investments in additive manufacturing are made just by some calculation numbers, or if there's a budget available. But you should focus more on the parts and the needed thing. And therefore, the boring question of make or buy is really an interesting one, because if you see the process from sketch to the end use part, it's a wide journey sometimes, and we also try to help companies answering that question. Yeah, and yeah, we so some people from our company, if you are up to some conversations, I already had a very good one. I'm very happy to talk to you guys, and if you have any questions about our services, feel free. And thanks for having us. Spain is a beautiful business trip for us. So thanks a lot.
Yeah, my name is Mark Meyer, project manager and focal point for additive manufacturing, and I'm happy to be here and to present our company, the Composite Technology Center, and also our view on how we look on additive manufacturing. A few words to our company. Where do we come from? So we are based in Stade, west from Hamburg, 30 minutes drive, and Stade is in Stade, there's also a big plant of Airbus, which is producing vertical tail planes. So the upper right fin at the end of the aircraft. And it's quite special because every Airbus program, so every A320, 330, 350 gets his VTP from Stade. So there's a long history in production with composite materials, because all of these VTPs are already made in the 80s with composite materials. And from this background, we were founded in 2001 in the middle of the Airbus plant. And then we moved out in 2004 in our own building, which was quite unique because, we have our own factory and Airbus confirmed industrial system there, which also helped us then for the support of the development of the A350. So as CTC, we supported Airbus in what kind of technologies we supposed for the aircraft manufacturing, so especially for large composite parts. And also we had the capacity to test everything in-house, not only the technology, we also could produce the parts which are then helped to qualify the A350 program. Yeah. The success, you can see here on the top, the A350 is already flying a couple of years, and then it moved on. So we had improvement projects, and also we expanded our fields. And today we're working in basically 4 fields. So we have the innovation fields, where we support Airbus and also from our side in various research projects. So on hydrogen, for example, or also on additive manufacturing. I will come to this later. To find new solutions, new technologies for the industry field. Then we have the point solution, where we support overall customers in the need of, if they have problems on specific technologies, on specific techno bricks, to come with our experience and come with our experts to visit their sites, to have a look and then propose further steps to to get rid of these problems. Then we have our own production in-house. So we are producing with thermoset materials most of the time at the moment. And we have our climate controlled environment where we are also capable to produce aircraft parts. And the last point, education. So we have our own education program, especially for composites, what kind of technologies, how the variety of technologies expand, what kind of materials are used, and also about the handling. So how is the post-processing of these parts possible? The way the CTC is thought, you can see here, so on the left, we have the startup plant, which is Airbus. And then in the middle, we have the CTC. And on the right, we have the research centers. And all around is called the CFK Valley. And CTC is right in the middle. So we are Airbus owned, but we are also free to look around to see at different companies, different research institutes, what kind of technologies they are evolving, and to check then how we can develop them and to bring further them into an industrial system like an Airbus environment. So normally, if you say, okay, you go for the TRL level, so how far the development reaches. So TRL 1 to 3, so getting a first idea, having some test parts. This is done then in the research centers, and then we can transform it also with the CTC from TRL 3 to TRL 6 to bring it into industrial level, and from TRL 6 or 7 to 9, which is then handed over to Airbus to go a bit further. Yeah, some facts. We are we growth. We are more than 80 employees at the moment, including our PhD students. So we have a deep collaboration, for example, with the University of Bremen or with the Federal Armed Forces University in Hamburg. So the PhD students are directly working at CTC in industrial projects to better link the fact of the need of industrialization and research systems to align into a production system. We are also integrated into the Airbus technology programs. So we are directly influencing the way and proposing the technologies, what can be in the future seen to have additional benefits from today. Yeah, we have also different offices, mainly in the north, but also one technology center in Augsburg, where we also mainly work with our defense and space colleagues there. Just roughly a few in our partners and customers. As I said, we are not only linked to Airbus, we have a variety of customers. We are able to speak with everyone to see what kind of new technologies, new systems, new programs, and also, for example, new simulation systems on the market. And then together with our collaborative partners, we mainly find consortiums to find solutions to bring it then at the end into the market. Coming to AM, so inside this CTC ecosystem, we also have our 3D hub, where we mainly focus on the material extrusion, which is also is the FCM technology here. So FCM stands for Fused Composite Manufacturing. Of course, also with our background, we are also focusing there, and we are also a reference shop inside Airbus for the FCM technology. Okay, I'm speeding a bit up. What kind of views or topics we are working on is, for example, digitalization. So we have also what we heard about qualification. So automatic certification of different print jobs to evaluating how the print was. Also combining it now with AI. So we are trying to to train our own AI model based on different failure types. The other thing is design and functionalization, also what we heard from Michael, is also a big part, and process development, and especially also material testing and designing. We have a variety of printers. So this is our biggest printer here, also in the focus of high performance thermoplastics. We have a Fortus 450 because it's the main system which is used in the aircraft or in the aircraft field. And then quite new, we have 2 elastomer printers where we see a lot of need for elastomeric parts, especially ceilings. For the FCM process, we have developed our own print heads, which can process filaments which are already infused with an endless carbon fiber. So you have the endless carbon fiber and then already impregnated with the resin system. This is the technology with the elastomer. So this is quite special because you have 2 components which you just directly mix before you apply it, and then after 8 seconds it cures out. So there's a big variety on the parts you can manufacture, so mainly flat parts, and you also are not directly able to have a lot of springs or moving around. So basically you need one continuous path for your part printing. Another functionalization type I brought, which was a project which ended 1 year ago. And here we did a demonstrator together with a consortium with Airbus, Safran, DLR, SVMS. And there we had a partition wall. So what you see here is an aircraft partition. When you're entering the aircraft, mainly on the right, you see it. And we combined different technologies here. So we have one FCM frame, which basically gives the rigidity of the partition itself. Then we had here a customer service seat with a seat heating. So here we had a directly TPU print, which integrated a seat heating. And also with Safran, they developed a specific light. So they printed the light distribution plate out of a resin system, so that you have an even light distribution that the light illuminates. And also some sensoring systems. So we used graphene material, which we've placed here as an example in a PLA system, which gave us the possibility to print sensoric systems. So here it's just a reference. So we have a handle, and if you pull it, then you can measure the force. Especially also the handle, or the handle is also special because it's also on the surface. They have specific material used for antimicrobial system. If you want to have a look on it further, it's also going to show at the aircraft exhibition ILA here in June. So there we are at the BMW booth to show also this project. Yeah, and as I'm running out of time, I think I skipped the last slide, and thank you for your time. Yeah, Keith?
So, sorry, because I think I am the last one. Welcome. I just
What to do the front table at that later on that take you.
Okay for you, see.
This is well you but that the at the he can get that
no?
It's a great corporate presentation.
Yeah. Okay, I represent Navantia. Navantia is a company for shipbuilding
we are focused on defense sector, and we have some shipbuilding in the north of Spain, in Galicia for frigates, and we have also in the south, in Cádiz, for corvettes, auxiliary ships, and patrols. And also in the east, in Cartagena, we have submarine sector. So in my area, design for manufacturing, we try to work together with the different programs to try to find different ways to do components and try to do it faster and better. That is the way. So the context today, just to very short, that we are in the shipyard face high workload. I think we had never had so many work until now. It's a special the work that we have in the south. We have more than 10 programs, different for different countries. We are working for the Spanish Navy, of course, and in the north we are also working from Spain and from United Kingdom to the different vessels, and in Cartagena for somebody. So at this moment, we try to do the things in a different way and try to do it faster. No, the naval construction is very traditional. We are using welding, machining, cutting, and so on. We have been doing at this for the last years, last decades. So we are trying with new technologies just to identify how to do it faster. It doesn't mean just that we need we want to buy the machine. We at this moment that we try to find the best technology applies to our market. So we are prefer to go together with different companies just to try to develop the best way to do this and the best material. We have at this moment a supply chain dependency. We have some components that are the lead times of the delivery times is 4 months or 5 months. So for at this moment it's not possible, and so we try to reduce these times, and we need to make the production more agile. We need to be flexible and resilient to the circumstances. So we have identified additive manufacturing as a critical enabling technology, and the objective is to reduce lead times, to strengthen industrial sovereignty, just to reduce the dependency for foreign suppliers, and we would like to optimize designs and performance for every component. To be focused on naval shipbuilding, we use complex structures. We think that we can use this technology for spare parts. There is no doubt, and probably our suppliers that we are in contact with them and discussing with them just to reduce our lead times. We use in our centers of repair in Cádiz, for example, for the U.S. Navy, that we are actually repairing some ships. For the U.S. Navy, we use this technology for the maintenance, and you use this technology for produce some parts that are obsolete. At this point, you need to take into account that our vessels, they are a large life, 25, 30 years. So what happens at the end of the life of every vessel is that we have some obsolescence to some components. So we use this technology for produce these small spare parts to introduce this part in our maintenance. We are using also in toolings. We are and the final purpose is just to lightweighting, just to reduce the weight of our vessel. If we reduce, if we at the end get to reduce the weight of our vessel, we can add more components for the defects. That is our purpose of our lessons. And we are in this point, we are trying to identify some elements or some components that are traditionally done by casting or forging. But the point here is the size. In naval vessel, for us, the most important point, the key difference from other technology is the size. So we are at this moment exploring different materials, composites and metal materials. Metal for those parts that are critical, that are we need some better performance requirements, and composites for others are not so critical. Advantage, I have just said shorter lead times, faster production of select components, reduce the complex of components. In some cases, this complex of, for example, for shaft lines of the vessel, we have many parts. So probably with another technology, we can reduce the part and do it in another way. The design freedom that allow us this technology. Of course, decentralized manufacturing. This is related to the sovereignty technology that we want, and improve sustainability. That is also in everything that we do. The challenge, certification and regulation. Probably we don't have the certification levels so much high as Airbus, but also for critical components we need some certification. Quality control in process monitoring, high initial equipment investment. I have said at this point, for the moment we are not in that point. Probably in the future, in our workshop, we will buy some technology, but at this moment we are just discussing, try to identify use case, try to apply this technology, and later we will see if it is feasible. And industrial scalability, the size is one of our key point, and the integration into existing processes, because in shipbuilding we are not going to discharge our traditional way of construction the whole of the vessel. It have no sense. So this new technology we have to use together and to add and to apply the best value of this new technology to our traditional way to construct the vessels. And the conclusion, just to be brief, additive manufacturing complements conventional manufacturing, boosts naval competitiveness via flexibility, speed and design optimization, and of course, a strong outlook at digitalization, qualification, industrial integration, and advance. So, thank you. Gracias.
minutos.
Oh, we still have a few minutes for questions in the round table. And we will start with Matt Bernaccio. You said that before that you are working a lot in training programs and so on. What are currently the main barriers for adoption this kind of technology?
What I found is that the main barrier is not price, which at the first side you say, hey, it's price to implement machine or something. It's that they don't have the type and they don't have the talent. It's at this point where I say, okay, if they don't have talent, if they don't have time, consultancy and also training people to know how to use 3D printers, how to design that. At the end, I think that it's maybe the most important thing. If you not design for additive manufacturing have no sense.
So this is the point where industry and talent, I think, that collides.
Thank you. Carles, we have been talking about the 3D printing, of course, but we know that you are an expert also in lean manufacturing. With you collaborate also with us in that kind of activities. I wanted to know how can lean manufacturing can be integrated in all these technologies that we have seen it today.
I think yes. When we think about 3D printing, everybody thinks in a batches, little batches, and so on. No, but I think that one of the most interesting thing of this technology is the flexibility. So when you see the other technologies, for example, pressing or grinding, CNC grinding, and so on, you need a setup time, an important setup time. So I think in the case of the 3D printing, we could reduce a lot. This could be, right? I think it could be very interesting to apply the lean manufacturing to this technology. I mean, it will be easier in this case because the same technology affords this flexibility to change of and to do little batches and to adapt the production and that. So when you speak about lean manufacturing, you want to flow. No? You don't want to produce as we produce in the 19th centuries with big batches and with you have to create flow with all the operations. And I think it could be very feasible with this technology to apply lean principles if we want to do a production, a serial production.
So you think it's possible to work?
I think it's possible, and probably it's easier than other technologies.
Because you have seen some examples in China, these large 3D printing machines that they are working for sectors like drone production and so on. So, well, Patrick, you say that German you describe lean as adding a production layer to extrusion. What does that mean in terms of integration with this existing
manufacturing? This touches on a couple of points that we heard here today already. So this morning, Hans Albrecht said that in 3D printing, you have a consolidating market, you have more players than you have in established markets. And when we started with the company, the thought the same thing. It doesn't make sense to reinvent the wheel and just build another large work machine, especially because large work machines are expensive. And if the initial investment scares off companies like Navantia, it scares off most people in the market. So we wanted to make something that you could add on to what you already have rather than having to buy everything again. Also, centering around the people that have to work with it. You have the engineers that need training. If we end up making another programming workflow, that you have a lot of training effort. So we wanted to make something that works with any software workflow you already have. So the people that are already working, that are already trained, can easily adopt it. So we find our information on the machine that's already there. You don't need us in the slicer. And the third one is the people that work with the machine on the factory floor. That's why we went for LED rather than laser. This has to work in a production environment. It's to integrate with other manufacturing processes, as Esther said. There's going to be people around. So we need to make sure that they're safe. That's why we added this layer on top and tried to not consider our product as something that exists in a vacuum, but rather something that layers on to the existing infrastructure that you already have, trying to just raise the quality a little bit further so you are able to address industrial applications. And that's then the production use case that we want to get to.
Take Ava, you have seen a lot of sectors that you are working, your technologies applying for this high value added sector. Where do you see the greatest opportunities for high performance printed polymers?
So I touched on this a little bit earlier. So PEEK being a biocompatible material, chemically inert, you can, and also being a common replacement for titanium and aluminum. You can kind of look at areas where you might want to do something like lightweighting, reduce total mass. So this is really important in aerospace. And also just kind of looking now that you can achieve these injection molded results, you can kind of look at cases where you have either injection molding or CTC and look at where you can either, reduce the quantity of parts that you want to make and just produce smaller volumes, or even reduce the amount of material waste. So for example, with cranial implants, a typical cranial implant, you're commonly machining most of the material away. So the savings there are usually around like 500 euros per implant, just on the material savings. So in cases of aerospace, PEEK is also material that has very low outgassing. So it's already listed in the NASA outgassing database as an improved material. So it's really great for weight reduction, lightweighting. And when we worked with an aerospace customer, they were looking at, the way to adopt was not to try to look at the most difficult thing, but try to look at kind of the lower hanging fruit. So we kind of made this matrix, and we looked at critical components and non-critical components, and structural components and non-structural components. So we started very low. We just looked at non-structural components that were non-critical. So things like brackets, for holding cable harnesses and stuff like that. If it breaks, it's not a catastrophic failure. And it's a non-structural part. So those are, I would say, the easiest opportunities to look at, where you have these kinds of benefits for low volume but high value.
You talk about PEEK, the PEEK materials, but you are using also other kind of materials.
Yes, correct. Yeah. So many people know about us as like the PEEK printing company, but we can now do this with any material. So if it's Ultim 9085, for example, we can also work with those materials.
Michael, you are also developing a high variety of products, no? In your opinion, what is the key factor behind these specifically lightweight components that you mentioned before?
I would say it's all about product implementation, understanding the application and starting from the sketch. Due to lightweight, I would say often we have products, when you want to do it with additive manufacturing, you have some problems because the design is for conventional manufacturing, and our target is always to skip it. That if we are ready with the design, the design matters most, like 90%. And when we are finished, the target is if they would go back to conventional manufacturing, the conventional manufacturers would say we cannot build this. So it's about turning the design of the part into on a level which is perfect for additive manufacturing. So just the design.
Okay, so lots. And Mark, how does the additive manufacturing fit in the Airbus complete supply chain? You mentioned that you're working with technological centers. You mentioned with your suppliers that they are around, and also directly to Airbus. How does, in a few words, fit this technology company?
If you have a look on the few or whole complete supply chain steps, so we have the development, and we have the production of an aircraft, and also the in-service area. And basically it fits all of the three. So for the development, we see a high rate for prototypes, or functional prototypes, doing fit checks, so like having the part on the engineer's desk as an early stage to represent the size, to get an idea what did I design here, and then also have the opportunity to bring it into an aircraft demonstrator to make some first test mounts and so on. So increasing the development or decreasing the development time is supporting there. Then in service, there, especially for the FFF technology in Hamburg, there's the speed shop, which is supporting the whole final assembly line with missing parts. So not that they are replacing the missing parts, but they are producing also dummies, which are then placed in the assembly line, which are then at the end or at the further step are removed and replaced by the original part. Also, it supports when you, for example, there's always a test flight for the customer against this aircraft. And there was one case, there was just a and air outlet fan missing. But the engineers said without this air outlet fan, the aircraft couldn't take off. So this would then cause a delay of 2 or 3 weeks before the test flight can happen, and then afterwards the customer can take his aircraft. So with additive manufacturing, it was possible to reproduce these fans within 24 hours, and the aircraft could take off at the next day. So this is also which supports the production and the customer service. And in service, it's also mainly focused at the moment at jigs and tools. So I think we had around some presentation today that an airline also printed its own tools. And this is also a point for Airbus to create tool designs which they can offer to the airlines to increase and have a more economical way for their maintaining processes.
Is there now Altia is a huge company that they are selling their products all over the world, and you are right now adopting, the additive manufacture. You mentioned before that the large products or parts are a big issue for your company. Why? Because of this, you don't find the right suppliers. You are not adopting this technology. Why is a big problem or big trouble to find out that kind of products?
Well, when we are talking about the big products of critical components, for example, some related to the SAF line of the vessel, in some way they are critical parts. So they are metallic. I think it's that critical part we can't use polymeric, and we need to use metallic. So with this point, we need to find the best technology, the best material. Actually, we are doing these components casting, more or less, and we are using traditional metals, and we are trying to search different metals, different components that we can produce this part. But it's difficult to find with a piece that probably weighs more than 300 kilograms. Is big. So just to find the robot, I think it can be in a small printer. When people talk about large component, 60 centimeters, for us is above 1 meter. Above 1 meter. So this is the key point for us. We'll try.
Thank you so much. Well,
now there's some question from the audience, so I think 5 minutes, of course, we can spend on that.
Okay, any questions? Seems very clear. Yes.
I was interested in another use cases. We all hear a lot of it. Movements in this segment from the US. Actually, are you aware what US does compared to Europe? How good are we, or are they faster? What is a comparison?
Well, it's true that the United States, they are moving faster. They are using this technology actually, and we are, we have said we are working with them in the maintenance of some destroyers that they have in Rota. In Avantia, that's the maintenance of Spanish ships and US Navy. And we are using this technology for spare parts. And with Meltio, with a company Novenders, we are doing some tests, introducing one printer on board and doing some components and some tests. So I think they are using, of course, in defense sector, they are using the additive manufacturing for the lot of components, drums, on. We are trying to talk and discuss with our suppliers, for example, for our suppliers of bulbs, pumps, and this a small component just to try to use this technology in order to reduce the time. And I think United States has this technology more introduced in their supply. So for many the diffuse they use this company, and they do some call for the industry. For example, for one company who is capable to pay 100 per month of small vessels, 7 liters, and they have these types of contests, and just to push the task. Where is the a bit far?
Yes. Yeah, for the guys who are doing consulting, we were speaking about aerospace, automotive, engineering, medical. So I just want to know if you see a 3D printing penetration into the fashion industry. Because after oil, automotive is coming fashion. How do you see the future for the fashion using 3D technology to create new textiles or new kind of textile we can use in a daily base like this one?
But I would say it's a niche so far, and without having more volume, it's difficult for many companies to use it. I think there are many good ideas in the market, and you see many things. But probably, I mean, the last 10 years were so difficult to turn like non-plastic or non-metal into a productivity level, and therefore I would say it's a long journey ahead. Yeah.
Honestly, this is quite a leading company in printing textiles on the polyjet methodology, but it's still in a kind of prototyping versions and all that.
Okay, so we have space to grow over. Good. That's what you want to hear.
Yeah, but also it's important not only the clothes that you are going to wear, also all the parts that are related to textile. So here in Catalonia, there's a lot of textile companies that are really old, but they have a problem that the machines go also old. So this is where 3D printing is starting to enter in these companies.
If I can add something there really quickly, it's commonly asking, like people are commonly asking this question: why don't we 3D print this? Why don't we 3D print that? But I think it's better to ask the question why we want to 3D print that, and I think we need to look for the value in 3D printing something. So we are already seeing, like for example, in 3D printed shoes, you can add a lot of value in changing the structure and changing the functionality of the shoe. And I think these are the questions that remain to be answered in terms of its adoption in the fashion industry. Are we saving money? Are we adding additional functionalities? So maybe there are new processes or new materials, like using recycled materials, that could be introduced that make it more attractive to adopt in the fashion industry, or making breathability improved, or integrating electronics or sensors or something like that make it easier to do with additive manufacturing than traditional methods. So I think that's a big question that needs to be answered.
By the way, the Mataró and the Maresme area is a very textile traditionally, and we organized some months ago together with the municipality an event like this, specifically for the textile industry. Some of the people some of the experts that they were here, they say that the luxury industry, accessory industry, also what you mentioned before, that they integrate some kind of sensors to develop some kind of technical textiles. They were plenty, and it's a long loss also. Any questions, or we go directly for the closing marks?
Okay, so
Okay. So
thank you very much for all the speakers and also the experience that you shared, and also, of course, all of you. So let's close the table, and then we make a picture and take closing marks. Thank you so much. Perfect.
So this is going to be brief, so don't worry about that. Well, I see I can do it at the same time, so I just lap, so we gain 1 minute.
All right.
So we've now come to the end of the Spanish-German conference on additive manufacturing. It has been a great pleasure to see so much interest, expertise, and openness for exchange here today. Over the course of the morning, we have had the opportunity to gain valuable insights into the current state and future potential of additive manufacturing as key technology for industrial innovation. First of all, I would like to thank all our speakers and moderators from Spain and Germany for their contributions, their time, and for sharing their experience, perspectives, and practical solutions with us. Throughout the conference, we have addressed additive manufacturing from several important angles, from strategic approaches and certified industrial production to advanced technologies, new materials, real-world applications, and concrete use cases from industry, as we just seen the case of Airbus or Navantia. At the same time, today's discussion have also shown that there are still important challenges ahead: certification, scalability, material performance, cost efficiency, and the integration of additive manufacturing into existing industrial processes. But precisely these challenges also open up significant opportunities for cooperation between companies, research institutions, technology centers, and industrial partners from Spain and Germany. My thanks also go to Technocampus for hosting us here today, and all partners and colleagues involved in the organization of this conference. I sincerely hope that this morning has been useful for you, that you take away new ideas, above all, new contacts for future projects and collaborations. That's why we are here. I would now like to invite you to continue the exchange during the cocktail and the bilateral meetings planned afterwards, I think from 3 p.m. on. Wish you a pleasant continuation of the day and many fruitful conversations. So, really thank you for having been here this morning. And now begins the important part.